or what the concentrations of mercury are. But this was the data collected up until 2008 and then published in 2010 and 11. So from the data collected by those researchers working within the atmospheric environment, we were able to establish as to, in terms of atmospheric emissions, what are the particulate mercury and the reactive gaseous mercury concentrations or estimations, because at that stage they needed an emission factor in terms of the model that they were using to find the correct data for South Africa. With this study, we were also able to now quantify and identify, when it comes to the aqueous environment, as to what the concentrations of mercury are. So we've also highlighted what are the impacted sites, and at that stage it was your Olifants, Upper Vaal and Inkomati. Remember, later on I will show you that these water management areas have now changed. We were able to look at what are the values for total mercury, how it relates to the global average, as well as methyl mercury, which is the more toxic component of mercury. We were able to then also analyze values and then compare our results towards international guideline values. In terms of sediment, again, we were able to identify that the most impacted water management areas are, again, Olifants, Upper Vaal and Inkomati, with the concentrations given. And then we find that since South Africa has a historical contamination site, those of you that know the KwaZulu-Natal province, we were able to sample in the VUT Umzimkhulu water management area at the time, and we still found high values for total mercury and methyl mercury in that area. And in this snapshot here, you will see the river system, the Umgeni river system, if it's not too small. I know that DFFE, Brenda, are still working with the historical contaminated site. DFFE is still working with that data, so if there's any queries or questions, then we can talk about that offline. So in terms of sediment, we then had the data for South Africa, and in terms of biota, we were able to see as to what is happening in the South African environment, especially around those water management areas where we've seen these impacts. So the highest were then in terms of methyl mercury in the Mvoti, Umzimkhulu water management area, but that was due to the historical contamination, and the second highest being in the Inkomati water management area. And all of that is explained in the paper that we published at the time. Fish, we were also able, it's not easy to sample fish, as the chair who can highlight to you. So I was yesterday very excited to see the data that he has since collected with his team in terms of especially your marine fish, etc., in terms of the national survey for South Africa, because I think that values can add to what we have. So luckily we found that for the methyl mercury, the concentrations were within the US EPA limit. And again, the legacy of the historical impacted site was still showing in terms of the data that we've collected. During our initial project in terms of South Africa, we also did wet deposition studies to also at Cape Point understand in terms of rain as to what are the concentrations in terms of mercury within our rainwater samples. And with that period of investigation, we were able to publish several papers. I'm just going to flash this information. So all of this data is out there in terms of what has been done when it comes to mercury analysis over South Africa, working with various international partners and organizations in order to understand the South African landscape. For the last conference that we had in terms of mercury as an global pollutant, we also produced 2 synthesis papers, and the synthesis papers were there to investigate the fact that we have this paucity in data between mercury studies done in the southern hemisphere versus the northern hemisphere. So again, it also gave us motivation as to why we need to continue collecting data to get a better data set for South Africa, but also as part of the other southern hemisphere countries that are doing mercury research. So we went through a period where we were now trying to get funding. Funding became an issue, and luckily we had a young stallion in our group of researchers. So Dr. Lindbergh Martin then said that we must continue to monitor. So we had the establishment of SAMNet, because SAMA was now not functioning anymore because people moving to different organizations. So in the SAMNet activities, we then started to continue with some of our aquatic ecosystem studies. We also wanted to make sure that we do train students so that they are able to sample, especially when it comes to the aquatic ecosystem, which is where I am confident in terms of the work, but also in terms of atmospheric monitoring. We also want the students then to investigate new techniques in how to look at mercury in the environment. We also needed an upgrade on equipment for sample analysis and expand the network for research done by the students and other researchers, ensuring that we include your NGOs, your governments, industries, etc., so that we can continue to reduce that paucity in data. And while we were designing all of what it is that we're going to look at, we found that the water management areas has now been reduced to 9. To 9, so we used that data and then we looked at where are we in terms of research capacity. So we then decided that let's continue in the Western Cape because it's easy for us to do that. And then also look at what is happening in the impacted water management area that is closely situated around the coal-fired power stations. So in terms of that, that is new work that we have been looking at, but we actually have been doing work on the Eerstekales River system in the water management area. As you can see, it's quite a long river on the western parts of the province. So that work is continuing, and we have a student also involved in terms of the sampling that's taking place. Linked to that in the Western Cape is another long river, which is the Berg River system, where we also are still monitoring. It starts, those of you that knows the Western Cape, it starts running from Franschhoek all the way down to the Atlantic Ocean there on the side of Veldrift. And recently, on a sampling trip, I took 2 students from Dr. Martin and Prof. Susan, Victor and Anesu, and as you can see, we then train them in terms of how sampling is done. It is not their field, but because they work in different compartments in terms of mercury studies, but you can speak to them and find out what they have learned, and they will also talk about their own studies later on. But to look at some of the data that we now found was that when we did the synthesis papers, they told us that there is no data in terms of soil. So I'm just showing you some of the concentrations that we found in terms of the ongoing studies. But for the first time, we now also have soil mercury data included in the data set. We continued with this activities, but we continued in terms of the VUT water management area. In July, like I said, we went out with the students to sample. And the students are Mvula and Lakeni. And I'm showing you the sampling sites that we've done. And once those results are published, and here I'm working with Prof. Michael Klink here at VUT in terms of monitoring the VAL water management area. So once that data is available, we will be able, and the students will be able to give you more information on what is happening on that side. So just to then conclude, so seeing that we now have a clearer picture of what is happening in mercury, we still see that there is a lot of work that various role players and various researchers can do in terms of studying the effects of the emissions, in terms of the impact, especially on the aquatic ecosystem, on human health. Yesterday we heard about coal being used in indoors in housing for cooking, etc. And all of that data also still needs to become part of the national survey and inventory, and also learning about the bioaccumulation that possibly is taking place, looking at what's happening from the oceans, and also other sources such as e-waste, and also to make sure that we fill the gaps in terms of the region that is, and researchers doing their part in terms of understanding mercury in the environment. And with that, I would just like to acknowledge all of the organizations and institutions that have been working with us over the years. So this was a snapshot in terms of the work that has been done, and there's room for many other role players to work with us in terms of taking this further. Thank you.
Thank you. Thank you, Prof. That was really informative. We have time for a few questions, so please feel free to pick Prof. Somerset's mind. Any questions?
Thank you very much, Prof, for the wonderful presentation. I'm just asking if you concentrate only on the contamination within water. Do you also extend it to the contamination in air? Or your study concentrates only on the water?
Prof,
Thank you.
Thank you for that question. My field is water, and Dr. Martin will give you a better picture in terms of the atmosphere. And then yesterday, if you remember, we also saw in terms of fish, what are the current studies being done. So all that compartments form part of the bigger puzzle to understand what is happening within our environment. So different researchers are working in the different compartments, and we just need to find out how we can best put that puzzle together so that when we present again, we can give a better a picture in terms of what is happening.
Any other questions?
May I add, when it comes to the aquatic ecosystem, because we have to sample, and there's different samples, one of the issues is always the cost of the analysis. That is also sometimes driving the frequency of sampling. That is why for us, we will do seasonal in terms of understanding what's happening in the winter versus the summer, or wet season versus dry season.
What is the acceptable amount of mercury that should be on the fish? Because I saw that you've actually done also research on your fish.
I think it is in one of the slides, because I can't remember that offhand. The US EPA limit is 300 nanograms per gram. So in terms of in fish, that is the value, and for these areas that we have studied, that is what we have found. Dr. Erasmus, did you have any higher values than that? It's also not in his study, also didn't have values exceeding that limit in terms of methyl mercury, because for fish, as a protein source, methyl mercury, which is the biological mercury, is the one that is the toxic part, because it will attack the nervous system of humans if they eat fish with high limits of mercury. And as we have the convention for mercury, which is the Minamata Convention, I don't know if you remember that is where the first cases of mercury poisoning were detected.
Yes, thank you very much. Prof, I wish to know what informs your choice of sampling sites. And what I wonder is, if you sample maybe close to industries, does it happen that you have high levels of mercury, and maybe when you go downstream, okay, I think I missed this part. But can you explain this one?
Thank you for the question. So when we set up the survey initially, we also didn't know as to where, but we know that these are some of the activities where mercury will be released. So our target was then to go to those specific sites and then see what do we find in terms of those sites, whether they are elevated or not. And like I've highlighted, we have a historic contaminated site. We knew about that, and it was difficult at the time also to get samples in order to just get baseline studies or baseline values to see what is the current situation at the time. But if there is plumes, you know, it will have to be information that is coming from a municipality or from any other a source that informs us, and then we have to go sample and investigate and see whether those values are high and exceeding the limits for South Africa or internationally.
Thank you very much for the interesting perspective and a bit of the history, which is always good to bear in mind. I just was interested for everybody in the audience, just, you know, based on what you were saying now about the methyl mercury, which labs in South Africa still have capacity to actually quantify methyl mercury? Because I know that a number of these studies were done at the CSR lab, which I believe is no more.
Yeah, thank you, Patricia. There's only one lab that is set up to do methyl mercury analysis, and that is the lab at the CSIR in Stellenbosch. But there's also a transition happening, and we can talk about that. But in terms of SAMNet, we also want to make sure that we bring that into the bigger activities of SAMNet so that we are able to analyze for methyl mercury.
Maybe just because of audience we are in here, I think it's important just to know we need to just do that with great caution, because you know, when analysing forage, you then have to also use the standards. And I don't know how many people in the audience are aware, but actually a very famous US chemist, professor, actually died. She was making, I believe, on the standard. She was wearing gloves, and one tiny drop got on her glove and got through it, and she died. So this is not something we want every student to be working on. So it's just something that as a community we need to also just be cautious about and strategic and plan very carefully so that we don't have any unintended consequences.
Yes, that's correct. And as you know, that Dr. Siobhan Walters went for training at University of Connecticut in terms of us establishing that lab, and also in terms of yesterday the question came up: how do we trust the data? And even there's also intercollaborative studies and data collected to make sure that the analysis conforms to standard.
Prof. Somerset, can you take back to the mercury levels in fish? Is that for your samples, those results that you got from your samples, then a specific size of fish that you guys are sampling? Because as we know, mercury bioaccumulates and biomagnifies as it goes up. And are these fish predator fish or just regular fish?
Alvin, thank you for that question. It was predatory fish, and I have to look at the publication to give you the specific name and details of the fish. I don't know if Dr. Erasmus wants to add to that in terms of the fish that you have sampled.
Yeah, so in the upper catchments in northeast where tigerfish are present, we also sampled that and got really high concentrations in the tigerfish. But the more omnivorous fish like catfish, they also had elevated concentrations, but we can also see within different trophic levels how it's higher in higher trophic levels.
I'm asking because it's pretty close to the US EPA limit, although the higher end is like 268, it can be classified on the unsafe side to eat. If the fish is still not in full adult that you sample and collect, by the time it reach full adult, it might be way over the limit.
Yeah, and maybe just to add in terms of, because these are for the highest impacted sites. And for this site where we have the historical contamination, I know that our Medical Research Council has also done research in terms of the risk for human health, and that publication is also available to see, because in some of the rural areas the only source of protein is fish.
All right. Thank you very much for this discussion and the presentation. I'm liking the interaction. And then our next presenter is Mr. Alvin Chow.
Do they have this one? On my last slide, I'll put that. Oh, it's on there. I can change the slide.
Yes, it should be.
Because I'm not sure the USB is, yeah. You have to put that USB on there in order to use it. Here. I got the same one.
Is it coming out?
Is it coming out? Oh, yeah. Okay. Okay, good morning, everyone. Okay, first I'd like to start by thanking the SOURCE, South African Weather Services, Dr. Linru Martin, and Professor Michael Kling for giving us opportunity to attend this symposium, and most importantly, allow us to give a talk to share our company's So if the other two species, RGM, which is ionic mercury, or so-called organic mercury, it cannot be directly measured. In order to measure ionic mercury or organic mercury, you have to do the sample preparation and convert it directly using atomic spectroscopy. You can do it. For RGM, most of it is like a highly soluble in water, so it can be so-called found in rain, snow, or condensates from humidity. Yeah. TPM normally is particulate bound, like I said, so it's mostly absorbed to particulate or dust and so on. Yeah. So the mercury species can be either elemental or even ionic itself as particulate mercury. So of these three forms of mercury, basically elemental mercury, as what Dr. Linwu Martin has said, it has a strong, so-called a very long transport endurance. So it can be, it can stays in the atmosphere for a period of time. So local polluter may not receive that kind of pollution. Instead, the remote area might receive the pollution from the origin pollution source. So it causes transboundary pollution issues. Yeah. Whereas RGM, which is highly soluble in water, can easily drop out in the atmosphere from rain or precipitation. So similarly, TPM is the same. So we call those GEM is a source of remote deposition, whereas RGM and TPM usually are local deposition. So this to the units is like 3 orders of magnitude difference, nanogram per cubic meter to picogram per cubic meter. So you can see that actually RGM and TPM is just a small fraction of the GEM, that concentration, or the TGM, which is total gaseous mercury concentration. So by measuring, we can say that by measuring GEM, we can almost represent the total TGM of mercury in the atmosphere. So that's the reason why most of people are trying to just measure GEM. So for sampling of GEM, as we know, one of the most established and reliable method is using gold amalgamation, or some call the gold standard. Yeah. The reason is because gold is other gases does not amalgamate. Tube, do a tube thermal desorption and measure it by atomic absorption or atomic fluorescence detector. So basically, no chemical treatment is required, no chemical is used at all, just using that gold amalgamation tube. But if you are using the passive sampler, usually the passive sampler is exposed to the environment for 3 to 12 months, depend on the mercury concentration or depend on the site condition. Yeah, then after bring back the passive sampler, you have to do the acid over a period of time, measure the mercury. After that, continue the next sampling and measure. So it gives you a continuous reading for the whole day, 7 days a week, 365 days per year. So as for RGM, the easiest, either you use the automated system from TechCran that can do the so-called sampling and measurement on RGM, which is also, I would say, like what Mr. Hattori said, it can be very expensive, the equipment, and it also require a lot of maintenance. Most of the other researchers, they are in Asia, they are doing it by rain sampling, by collecting rainwater. Then you can actually do the acid digestion on the water. After that, measure it by stannous chloride reduction cold vapor atomic fluorescent detector. Yeah. Then PBM, you can collect it by Teflon filter or the quartz fiber filter. If you are using a Teflon filter, you have to do the acid digestion and measure it by the wet chemistry reduction. It's cold vapor AFS. Yeah. But if you are using the quartz fiber filter, you can actually do the thermal decomposition. You might want to ask why Teflon TPFE filter, it's not allowed to use thermal decomposition, because PTFE filter basically is a fluorinated polymer. Fluorine compound or halogen compound is hazardous to the combustion catalyst in thermal decomposition system. So normally we don't suggest to run it directly on thermal decomposition. So if you want to do TPM and using thermal decomposition technique, try to use the quartz fiber filter. I will go into more detail later on about what quartz fiber filter that we suggest and the procedure. So next is the analytical solution that is offered from Nippon Instrument. First, a sampling technique. If you want to do the gold amalgamation manual active sampling, we do offer the sampling kit. It's called the SK1000. This procedure is according to what Mr. Hattori has explained. EDA has explained, because it's following the manual of measurements method of hazardous air pollutant under the Ministry of Environment, Japan. And basically, the gold amalgamation trap is a magnified. You can see it clearly. So basically, it's not pure gold. It's a gold compound coated on a datomite. Datomite is a kind of earth, so-called natural earth material. It's a form of silica that we coat on it. And we have been doing this for more than 40 years. Since the company started in 1978, gold amalgamation has been one of our key, or thermal decomposition is our first instrument that we developed at the time. So using thermal decomposition, gold amalgamation technique is necessary. So it was developed at the time until so. With that gold coating technology, we know it's very reliable. And these gold traps usually are highly durable and reusable. Yeah, I have seen it, instrument running the gold trap, inside the instrument running and running. After 7-8 years I'm there, they are still running the same gold trap on it, and the instrument is continue running samples. So it's not a consumable, but it can be damaged in some ways. For example, accidentally you flush water through that gold trap, then it might be damaged, the gold trap. Or else, if you keep the gold sand dry and clean condition, it can continue to reuse. Yeah. So this is also one of the pictures that I have seen from Mr. Hattori's slide. Basically, the sampling for active gold amalgamation sampling, basically connect with soda lime to remove humidity and some acidic gas from the atmosphere before the mercury is collected on the gold amalgamation trap using a sampling pump. I will explain later on. So this is the same setup for the active gold amalgamation sampling. So choice of instrument. After collecting the sample on the gold amalgamation trap, there are different choice of models of instrument that we offer that can do the measurement. First model is the WA series, we call it WA5, the 5th generation series. A stands for atomic absorption detector, or if you want the highly sensitive atomic fluorescence detector, you can choose the 5F. Yeah. So simply just take the gold trap out, yeah, slot it through that heater, and just press the start. 5 minutes later, the tube, it dissolves the mercury out the tube, goes into the second amalgamation trap, purifies the mercury, dissolve again, goes to the detector. So total takes about 5 minutes per measurement, and the tube is clean again. That sampling tube, after take measurement of the mercury, you can remove it out, seal it back in the container, do it for next sampling. Yeah, so it's pretty simple, no reagents required. Or if you have many traps to dissolve and it doesn't want to, prefers to have automation, you can actually work with the auto sampler. You can buy the thermal dissolve auto sampler with 30 position, Just put the tubes into the tube holder. After that, put it in your auto sampler. Start on the software one by one, it thermal dissolves the tube. And all the 30 tubes will be done in no time. Or like Dr. Lin Ru Martin in VUT here, they have the MA3000 that is used for the MERPAS analysis. And now comes the short tube. Remember the N65, why we have an N65 tube. N65 tube is for the newer series called the MA3 Solo, which is also a thermal decomposition analyzer, but it's a small, highly portable. Yeah, it weighs only about 13 kilograms, does not require any carrier gas, compressed gas to do, just using an ambient air as a carrier gas. You can buy the gas tube kit, the short tube, after sampling, put a tube on it, you do a thermal decomposition on the tube. Yeah, this is the typical results of the manual active sampling, dual samples with one travel blank and so on. Next, passive sampler. As we know, passive sampler is a very so-called highly useful sampling device that does not leak electricity to operate. It can be easily installed. And it can be deployed anywhere. Yeah, so basically, it's ideal for sampling for temporal resolution, which is not required. Yeah, and utility site is restricted or limited. But majority of these passive sampler, they are carbon powders, sulfur impregnated carbon powders. Why must it be sulfur impregnated? Because mercury itself, when you collect it try to collect it on a carbon itself, it's just a physical absorption. In order to stabilize the mercury and not losing it, get it stable, you need to be chemically bound. So sulfur is one of the compound that is also have a strong affinity to mercury. It reacts very well and chemically bond it, so it can be stabilized. So it contains sulfur. So sampling is very easy for passive sampler, but when you do the analysis, it's complicated because of the sulfur content. Because in analytical chemistry, as atomic absorption, sulfur is the biggest enemy to mercury because sulfur almost overlaps the wavelength of mercury. So if sulfur content is high, it will overlap the mercury. So most of the time, if you use things like atomic ICP OES, optical emission detector, usually sulfur might cross over, in terms of higher level, might cross over to the mercury wavelength. Once it crosses over the mercury wavelength, the mercury is hidden below the baseline of sulfur. So the results of ICP, they will just simply report ND. ND doesn't mean there's no mercury, it's non-detectable. Non-detectable, that means the instrument, the detector is not sensitive enough to do is always by atomic, so-called cold vapor atomic absorption. That's why I did maybe last week in NWU, we have a discussion. So actually, ICP OES and ICP MS is not an accredited method to actually, or certified method to do for mercury measurement. If you look at the US EPA ICP OES method, mercury is listed not the primary element, it's a secondary element, but the detection accuracy is pretty bad for that, and it's on the higher levels, not on the low levels. Yeah. So this is the procedure how we do the MERPAS by thermal decomposition. So because MERPAS so-called the passive sampler itself contains sulfur, so we have to neutralize away the sulfur to avoid the sulfur after combustion from so-called reacting with the catalyst in the system. So we use an alkaline powder, typically sodium carbonate. Yeah, we so-called sodium carbonate itself to neutralize the excess sulfur from combustion, then to prevent the excess sulfur from contaminating it and to also contaminate the flow path. So this is how we do, load the sample into the sample holder, simply cover it with a layer of sodium carbonate. So whenever combustion, the sulfur try to release out from the ceramic board or the board itself, it just react with the alkaline powder and so-called neutralized by the alkaline powder. So this is the typical results of a MERPAS or a passive sampler that we are running. And if you want to do the GEM on the automated ways, so this is the model AM6F that Nippon Instruments offer. It's based on the technique of GO amalgamation, periodic GO amalgamation, after that measured by cold vapor atomic fluorescent detector. So system like the automated system, all these are the advantage. Unmanned, it runs 24 hours, 7 days a week, 365 days non-stop. It has high resolution. Typically, the system produces every 10 minutes one data. So an hour, you get 6 data out of it. Yeah, so it's also a good way you can track pollution sources. You have any emission, unlike passive samplers or the active matter sampling where you do it once a month, you're never able to get enough resolution to detect any pollution source or hotspots. An advantage, this is also one of the advantage of the system, because most of this system, like what Dr. Lin Wu Martin has, is that we have one unit installed in Cape Point, so you can't simply just go every day to Cape Point just to get the data or to see the results. So we got the system comes with a software that is able to send the data on a daily basis to your computer or to your phone that is tagged to the email. So any device that you can receive your email, you can receive the data. So this is the typical results of continuous monitoring measurement from AM6F. And we also have, we also have this unit called the EMP Go Plus, which is also right in front here. It's an EMP portable atomic absorption detector coupled with a Go amalgamation in front. So Go amalgamation objective is to pre-concentrate the mercury from the ambient air that you sample. After that, dissolve and measure it on the atomic absorption detector. So this is a typical detection limit and we are able to get on this machine. So this is one of the applications that is advantage. The instrument is GPS enabled, so you can actually put it in the car, drive around, stop in certain point, do certain number of samplings over a period of time, collect the data, and every data is tagged with the GPS coordinate. So when you come back, you can plot the location exactly where you get the mercury concentration. Or you can set it in the continuous mode. It can run continuously, using an AC power supply source and so on. So that's all that solution that we can offer for GEM. And now we go on to RGM. So RGM, like I said, is highly soluble, water soluble. So typically we collect it as rainwater or precipitate from humidity. So as you know, RGM is just a fraction of the GM content. So extreme care must be taken because we are doing not just trace level. Perhaps you are going to ultra trace. It's going to be a PPT or even the sub PPT levels. So most of measurements are all in the picogram level now. So typically, most of the rain sampler must be customized for mercury. As we know, mercury is has high affinity to many kind of materials. So most of the rain sampler that you use for acid rains may not be suitable for mercury collections. The pathway has to be changed to Teflon or quartz, so-called borosilicate glass to collect it. It's just some simply just put in the normal plastic bottles and so on. Yeah. And the bottles must be pre-acid clean, etc. So After collecting the rain sample, how do you measure? We have a system called the RS7, the latest one, the RS7000F, which is a fluorescent detector, coupled with the Sampra 3F, which is the auto sampler itself. Yeah, so it does operates full automated for US. Reduction and measurement by gold amalgamation and fluorescent detector. So these are some of the typical samples that we analyze, for example, the snow condensed or snow precipitates and so on. And this is one of the latest data that is 7000F is installed in Taiwan under National Central University. National Central University is a central position for APMNN, a group which is Asia Pacific Mercury Monitoring Network, which is operating in Asia Pacific right now. NCU actually collects all the samples, rainwater samples from regional countries. I think as now maybe we have 15 countries. Yeah, 15 countries. So all these rainwater samples, whenever they have collected, they'll send back to NCU. NCU has the facilities to do all the measurement. So this 7000F was there for evaluation, and this is a report that was generated just recently, yeah, from the researchers to us. So one of the advantages, a unit actually comes with EPA, QA, QC so-called software itself. So after analysis, automatically the report will be generated, calculating your MDL also, not just the results accuracy. Last but not least, TPM. So TPM is particulate bound mercury. Yeah, it can exist in PM10 or PM2.5. So typically cause local deposition, as we know, gravitational sedimentation and so on. Yeah. So sampling of TPM, typically we use the quartz fiber filter, which I explained earlier on, because it can be directly ran on the thermal decomposition machine. Why is it important to directly run on the machine? Because just like RGM, TPM, mercury content is just a fraction of GEM. So special care must be taken if you have to put the sample through acid digestion, lots of preparation. Yeah, you can minimize the human handling error. So that's the reason why, together, some cooperation with National Institute for Minamata Disease, which the researchers suggested this technique, and we actually did the evaluation, and it was very good and reliable. And as for also special care must be taken, yeah, because when you buy the quartz fiber filter, it might have some level of mercury blanks. If you don't correct away the blank, it might be affecting to your results. So the best to condition the quartz fiber filter, because quartz is resistant to temperature, just put it in the muffle furnace for 3 hours at 750 degrees. Then it cleans out all the mercury. That your quartz fiber filter can be totally clean for the new sampling. And this is a sampling way, yeah, typical sampling volume, because the mercury content is very low. So normally for TPM, we sample at very high flow rate, between 3 to 10 liters per minute for 24 hours or even longer. Then after finish, bring it back to lab, simply take the quartz fiber filter from the sampling container, because quartz fiber filter is, it's just flexible. And just press the start. It's simple. There's no chemical reagent required. So these are typical results that we get. You can see the concentration levels are also very low. Yeah, even running for 24 hours. So those are all the solutions that we have for, like I explained earlier on, for atmospheric mercury. Yeah, but if you want to do things like biota, yeah, water, soil, typically the MA series, thermal decomposition is one of the best techniques to do, because it's easy, no chemical preparation required. Yeah, or people in the petroleum industry, or the people from CESO yesterday, their finished product, for example, the gasoline that they produce from the coal gasification, because mercury in coal is pretty high. So once you do the gasification, your product will also have traces of mercury in there. 100% organic. So usually we does the simple way. Just use a GC injector, fill the sample, gasoline as valve, GC injector, put an air liquid, feed it straight into the combustion chamber, burn it, collect the mercury by gold amalgamation, and measure it by atomic fluorescent detector. So most of these petroleum instruments that we have are all accredited or tested to comply to the ASTM method. Yes. Yeah. So as for gas, we also have system that is for stacked gas emission, fuel gas itself. Yeah. So I hope it's not too fast, and it's too many things to cover in a short time. So I hope I have extensive enough to give you some idea what we have. But if you have further question, I will be here the whole day. We can discuss it privately. Yeah. So for that, I can take any question from.
Thank you once more. I'm very, very thankful. Published any work on how the reaction mechanism
So far, I've started working with. As I know, generally, because it's a form of combustion, if you talk about direct measurement by using high temperature to burn the sample with a presence of oxygen, it's an oxide product. So mercury will be there, and mercury oxide. As its elemental form in a detector. So you have to make sure that the mercury is elemental. Moreover, gold amalgamation only works well with elemental mercury. So-called all the compounds are being combusted, including mercury comes out as an oxide. It's being pushed through a catalyst, which is a metal oxide catalyst. Metal oxide catalyst objective is to further break down, remove the oxygen, and letting the elemental mercury through. So it's two-step: combust, decompose. This is what generally I understand about the concept itself. In terms of chemical formulas, balancing the equation, we may not have those data back in the office.
I'm sorry, just as a follow-up. I take it thermic, not exothermic.
mercury in terms of the TPM, your total particle? Contributor to the TPM, because I can see they do analysis in terms of the dust.
Yes, like I said, the mercury species that's absorbed to TPM as dust or dust particles or suspended solids in this environment is also is either elemental mercury or it can be ionic mercury also. So it's an atmospheric pollution. So in an area where, for example, you are sampling close to the power plant right now, whatever you are doing GEM, we might be missing out the dust that is coming out from the top of the stack, which could be PBM. But if you are sampling it from a background area that in the countryside there's no industrial at all, perhaps the TPM has no contribution at all. Yeah, so typically TPM application is applied to those areas there's a high levels of emissions as particulate into the environment. Yes.
Thank you very much. I just was interested to see that for the TPM you were using nickel boats and not quartz boats for such low concentrations. Do you not have issues there?
No, not TPM. Actually, the passive sampler.
No, when they were folding the paper.
Yes, it's not the.
Don't worry.
Okay, yeah, I will show it. Yeah,
Okay.
it's a ceramic boat that we use. Actually,
Ceramic,
perhaps
oh, I
it's
see.
I think it's a forceps that they are using
Oh,
to
that
fold
was
it.
it,
Yes,
okay.
yeah, from the outside, but not contacting on the samples itself.
Oh, okay.
Yes.
And then my second question is, in a number of your slides you showed recoveries. What was the experimental method to actually determine the recoveries?
The recoveries itself, we do try to inject back a check standard, a known standard that we prepared. For example, with a known volume, we know we are the expected amount of mercury. So it's as ionic mercury as a liquid standard to do it as a check standard right now. Yeah, but some samples we do use CRMs if there are closed CRMs that's available. For example, for MERPAS, we know that the CRM available is one kind of coal, a bituminous coal that's available from NIST. We do use that. And for example, other applications like blood and urine, we do have those CRM. We use that to check it back as a recovery. Yeah.
So I must sound like a broken record at this point, but
Yeah.
on the website, sorry, I can speak loud now, but
Yeah.
so on the website it states that the limit of detection of the Gold Plus
Yeah.
is 2.3 nanograms,
Yeah.
right? But on
Yeah.
the slide you said it's 0.11. So is
Yes.
what's displayed on the website then the limit of quantification, maybe?
Yes. Yeah.
Is that correct?
Yes, I think initially the instrument has to continuously tested, improve, optimize to get better and better. Yeah. And also I would say the detection limit or the quantification limit is quite. I would say if you use it depends on the quality, so-called the condition of the unit, the detector itself, the flow path. Yeah, this instrument cannot be always maintained in a tip-top condition. For example, if you remove the detector for other kind of measurements, which is already contaminating the flow path, when you put it back to the so-called Gold Plus, your background will be higher. Once your background is higher, your quantification limit will also be higher. Yes, yes, sure. Okay,
Thank you, Alvin. That was really informative. So our next presenter is online, and Mr. Rico Europeo will talk about emerging mercury issues.
Hi, good morning, everybody. Can you hear me okay? Can you hear me okay? I'm talking. Hello? Can you hear me okay? I'm talking. Can you hear me? Can you hear me now? Hello? Hello? Can you hear me now? Can you hear me now? I'm talking. Can you hear me now? I'm talking. Can you hear me now? Check, check, check. Check, 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 check. Can you hear me now?
I try again, Lago.
I'm talking. Can you hear me now?
He's talking from the side. Maybe it's not.
Can you hear me now?
Like this one.
Can you hear me now? Can you hear me now? And now? Check, 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 check,
I'm just
check, check,
I'm
check.
good right now.
check, 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 check. Speak again, Rico. Yeah, I'm speaking. Can you hear me now? Still speaking. Can you hear me now? Still talking. Playing some music. Check, check, check. Is it okay? Check, okay. Check, check, check. Okay. Check, 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 check.
You can start it.
Okay, so you can hear me fine.
Yes, we can hear you. Yes, we can hear you now.
Okay, great, thank you. I think I've said check 1,000 times. Good morning, everybody, and I'm sorry that I couldn't be there in person, but thank you very much for the opportunity. My name is Rika Europida. For those of you that might not know me, I work for an organization called Groundwork, and we are an environmental justice organization celebrating our 25th year. And of those 25 years, I've been working on mercury for about 20 of those years. Like most NGOs around the world, we generally work in networks, in bigger networks, so that we can pool our resources and pool our expertise. The network that I work with, the global group that I work with, is called the Zero Mercury Working Group. We were formed in 2005 with the aim to reduce or eliminate mercury supply, use, emissions, exposure, and at the time advocating for a global mercury treaty, which eventually became the Minamata Convention, and now for the implementation of that treaty. And we have about 110 members now, in over 55 countries at the last count. In particular, we have three key issues in our focus area at the moment that we think are massive global problems, and we see those problems happening in South Africa. And the three problems are mercury that is being added to skin lightening creams, and that is routinely used by many people around the world, with very little controls about the trade in the mercury compounds that go into these skin lightening creams. The mercury compounds we're talking about are things like mercury chloride, ammoniated mercury, etc. And what we are routinely doing is having a close eye on the policy framework for skin lightening creams through the Minamata Convention, but we are also looking at how they are moving around the world, the supply and trade of them, where they're being sold, where they're being manufactured, and we are routinely testing them to test the mercury levels in those skin lightening creams. The second big thematic area that we think is a problem is mercury in dental amalgam, mercury in dentistry. It's been in main phased out in most of the developed world, but in low middle income countries there is still mercury used in amalgam, but also, more importantly, the legacy mercury that still exists in people's teeth, is something that we are concerned about. And then the third big problem that we are worried about is mercury that's been used in artisanal small-scale gold mining. And I'll talk a little bit about that towards the end of the presentation. So coming to mercury in skin lightening creams, we have, since 2017, been routinely buying and looking for products in spaza shops, in informal markets, being sold on online platforms. We've been looking at these skin lightening creams, and we've been buying them, and we've been sampling them. And as you can see, the correlation between the black shaded bars and the green shaded bars, most of these skin lightening creams that we buy and we test, we find mercury in them above the 1 ppm threshold. And this is the threshold that is stipulated in the Minamata Convention. In South Africa, we have had laws that don't allow the use of mercury in cosmetics since the 1990s, since the early 1990s, and yet in all of the samples that we buy in South Africa, online or in spaza shops, and these are available everywhere all the time, we find mercury in them. And the reason we think it's a problem, and it continues to be a problem, is because it is ingrained in many different cultures. It is something that is deep rooted. This idea that lighter skin, kind of Eurocentric beauty standards, that is constantly bombarded on people through advertising in television, in social media, that this drives this continual high demand for it. So people are continually looking for these creams, even though when we test these creams and we try to understand the extent of the mercury in them, we find that the mercury levels in people are very, very high, and they exceed the background levels that were found in the global mercury assessment. This is a slide that summarizes a systematic review that was recently done in 2023. And the headline finding out of this is that 2/3 of these skin lightening users had these very high levels of mercury in their biological samples. The extent to which it's the skin lightening creams contributing, to the elevated levels of mercury is not known exactly, but we know that there are tens of millions, if not hundreds of millions of people that are using skin lightening products almost every single day. And we know that from the sampling that we've done, looking at the mercury concentrations in the skin lightening creams, that we are finding routinely, we are finding mercury in them. Just to kind of give you a quick and dirty estimate, this is an estimate that we've done, and try to think about how much of these mercury compounds are used in the production and the sales of all these skin lightening creams. Just looking at Pakistan and thinking about its global share of global production, and thinking of how much they are using in these skin lightening creams based on an estimated concentration in each unit that is sold, we think that anything between 100 and 120 metric tons of mercury are being used or at least mercury compounds are being used in these skin lightening creams. And we estimate that there are approximately 60 million plus users of these skin lightening creams. So the way we are thinking about this is that mercury in skin lightening creams is almost like the new artisanal small-scale gold mining of the world. The mercury compounds are not banned or limited by the convention, and they are still traded freely. And when they are added to these creams are traded globally and sold on global markets, either through digital platforms. So it's like there is no control. These creams are moving around the world through porous borders. They're not being tested routinely. And the compounds that are used, the mercury compounds that are used to make them are not banned by global policy, and for that reason, they are not regulated under national laws. And then there's the difficulty in regulating the online retailers themselves, and making them liable for selling either illegal or unsafe products. If we look at the liability rules for these e-commerce platforms, it's not 100% clear that they are responsible for the safety of the products that they are actually selling, and that they should verify either through third party or a kind of a home country legal representation, that they should verify that the products are mercury free or safe. So it becomes even more difficult to regulate them in this context. Coming to the dental amalgam, just from a kind of a global snapshot, the global average of mercury in dental amalgam is about 0.8 grams per amalgam capsule. And in the most recent global mercury assessment from 2013 to 2018, mercury in dental use accounted for between, or the estimate was for between 270 to 340 metric tons globally a year, with at least a third, if not more than that, entering the solid waste stream. And that's the main problem with amalgam, is that all of the mercury that is either stored in people's mouths or that is still used in dental amalgam globally is likely leaching out and leaking into the environment through multiple routes. And ultimately, when it gets into the environment, it contaminates fish mainly, and we know that at least a third of the world's population rely on fish as their primary source of protein, as we heard earlier today from one of the speakers. Now, in South Africa, the first Minamata report was submitted in 2021. We now have mercury regulations, and within those there is a section dealing on amalgam. The estimate from South Africa is that approximately 2.5 tons of mercury is released each year. But that was mistaken. That was based on an underestimate. In our Minamata initial assessment, they used 0.3 grams as the average in amalgam, whereas that should be 0.8 grams. So anything up to 7 tons of mercury per year could be released by our regulations. In our national oral health policy and strategy, the phase down of amalgam by 40% is outlined, but it's very likely that the Minamata Convention the annex dealing with amalgam will be revised at this year's Conference of the Parties, and that a global phase-out date for 2030 will be set. So no more amalgam from 2030. And this is what we see. This is the reality in South Africa. fish testing by the CSIR, mercury in fish. Generally, we know that the bigger the fish or the more predatory the fish species, the higher the mercury concentrations in South African fish. And we pretty much see this everywhere. Professor Leslie Petrick from UWC just recently did some water testing from outfalls in the Western Cape region around Cape Town. They did some metals analysis, and they generally found mercury in all of their samples. And then the third big issue in South Africa and around the world is artisanal small-scale gold mining. And this is compounded in South Africa for a variety of reasons. The first is that between 1994 and today, approximately 500,000 miners from the gold mining, from the coal mining, platinum mining sector have been laid off in South Africa. And they are not just South Africans, but they are from the SADC region, from the Southern African region. So we know that the migrant labor system for mining in South Africa means that miners come from the whole Southern African region. Now, those miners have lost their jobs, and a lot of them have very limited opportunity for livelihood strategies back home. And in South Africa in particular, we have many abandoned gold mines. In total, there are about 6,000 abandoned mines in South Africa, according to the DMRE. Many of those are considered high risk. At least a third of those are abandoned gold mines. And because this is an illegal activity, the picture on the bottom right is from Stilfontein when those miners were trapped underground and many of them lost their lives. Because it is illegal, the activity goes underground. The activity is done in informal settings. Worst practices are used. If you look at the picture on the top right, that's an example of a ball mill. The crushed ore is put in there, and a lot of mercury, more mercury that is needed, is poured into that, and it's rotated to try and amalgamate the gold. And why will remain a big problem, not just in South Africa, but globally, is because the price of gold is at the highest it's ever been. There is the biggest gold rush that is happening globally, and I know I sound like a broken record, but in particular now, we are in the midst of literally the biggest gold rush. A miner, an artisanal miner, will get pretty close to what the spot price of gold is. So that is about 2,500 Rand per gram of gold. The price of gold is over $4,000 per ounce, and that equates almost to 75,000 Rand. So for a gold miner, it is a very, very it's very desirable activity because you can earn a good living out of gold mining if you know what you're doing. So coming to the conclusion of this presentation, there are lots of knowledge gaps that we have. The trade in mercury compounds is especially problematic in South Africa. We have to understand that. We have to understand, where the mercury is coming from. We need better analytical tools to measure and sample mercury in especially skin creams. The National Department of Health that is responsible for governing mercury in skin creams is largely absent from our Department of Environmental Affairs regulatory efforts at controlling mercury in skin creams. We need to relink and figure out how those two national departments work together. We need to do more bio-monitoring, especially in the global south. And we also need to have better repositories for information and data. And I think that's the end of the presentation. Thank you.
Thank you, Rico. Any questions for Rico?
Thank you very much. Can you hear my question?
Can you hear, they want to ask you a few questions, Rico? Can you hear them over the mic?
I can hear you, but I can't hear anybody else.
Okay, just speak quick.
Hello, can you hear me? Oh, okay. Thank you very much for a wonderful presentation. I've seen the results that you have shown, some particularly with the fish samples that was done before. So I also want to check with you if maybe, because it looks like when you talk about atmosphere, we're talking about fishes, water, air, but there are plants that are able to accumulate mercury in their system. And some of the creams that you are referring to are made from that plant as part of the formulation. So probably maybe if one of the sources that you can check might be the plants themselves, which most of the creams will find that one of the ingredients are a particular plant which is used for skin treatment. So I would suggest that maybe to increase your scope to also include these plants, because they are able to save this mercury into their vacuoles. So probably maybe it's one of the things in terms of, if you look at the atmospheric impact, also the plants should be looked into. Thank you.
Yeah, thank you so much for that question and the commentary. Mercury is an element, so wherever mercury occurs naturally in the environment, you will find that plants will bioaccumulate mercury. So in South African coals, most of our coals, our bituminous coals, have a concentration of about 0.05. It might be milligrams or parts per million of mercury in our coal, and that is the legacy of the concentration of mercury in those plants that form that coal. I think that the bigger issue, though, that you allude to, is that we need to do more biomonitoring. We need to do more fish biomonitoring in South Africa. We need to have a national fish biomonitoring system at the very minimum, I think. And we have to do more biomonitoring in people, especially high-risk populations in and around artisanal small-scale gold mining sites. I know that once the concentrate once gold is amalgamated from the concentrate trade in these ASGM sites, I know that there is open burning of that amalgam in communities. And when it's underground in hostels, for example, hostels around mines, I know that open burning of that amalgam happens in the actual hostel where people live, not just young men, but also families. So, we have to do much more in terms of biomonitoring in South Africa to get a better sense of the impact of mercury exposure. Thanks.
We got one more question coming up, Rico.
Thank you, Rico, for the presentation.
Please go ahead.
It's mute.
Yeah, you can go ahead.
Oh, okay. Thank you for the presentation. You touched on something that is critically nightmare in South Africa, which is the illegal mining and the use of mercury thereof. I think with all the efforts that we have made in terms of proving the efficiency of mining and extracting gold using cyanide, even though it's at the 90%, but the most challenge is that the cost is what we find ourselves, and readily available material that is used for that extraction purpose. For example, mercury, all the illegal miners know where to get it. We don't know that it's still available, but they know where to get it. And the biggest challenge that we are having is that it's relatively cheaper than the cyanide that is in the market, and it's known to extract this gold. Even with the tools that the illegal miners are using, they know it works because they were working in the mine at some point, and they were using similar models to do the bottle rolls. They were doing the leaching. They know how the resin in pulp works, so they're using the similar model, but using the mercury. And because it is less complex to do the extraction using the mercury than it is with cyanide. So I think with that, it's a no-winning situation. It's a Pandora's box. And the only thing for us to stop is the accessibility of the cyanide and to relatively lower the cost there. Thank you.
Thank you for that. I think I caught little bits and pieces of it, but the gist I understand is the use of cyanide to extract the gold out of the tailings, or the use of cyanide together with mercury. Now, under the Global Mercury Assessment and UNEP's kind of understanding of artisanal small-scale gold mining, the use of cyanide together with mercury is considered one of the very worst practices. And that's because the cyanide mobilizes the mercury even more. And where it is done, we need to try to understand that better. We should be encouraging the use of cyanide rather than the use of mercury. Even though, artisanal miners are very wary and scared of using cyanide. If they are taught how to properly use cyanide, it is more effective for them. They get more gold, and it is also safer for them and the communities that they live with in the long term. Thank you.
Thank you, Rico, for that. I understand. I truly agree with you. What I was saying is that the artisanal miners, they cannot access cyanide because of the regularities and the cost that is associated with it. And with that, they don't want to use it. Not that they're using the cyanide combined with mercury. So even though some of them are actually trained on how to use the cyanide, but because of the complexity of the method associated with cyanide, they are preferring the easier model and the less excessive, which is the mercury to extract the gold, rather than the more efficient cyanide that is proven that it can extract more gold. So they are not looking at the efficiency of the extraction, but they're rather looking at the easier way to do more than what they are extracting. Thank you.
Thank you so much. I agree totally with everything you've said, and I agree with you that the use of mercury is far, far worse and long-reaching than the use of cyanide, and we should be encouraging them to use cyanide and not mercury.
Question to the audience and yourself online is many moons back we done work with the CSR Mining Tech, the SAP's Gold and Diamond branch, and also looking at artisanal miners. There was understanding the risk of mercury exposure, but I believe also within Workplace Health Without Borders there was an initiative to develop a technique that was cheap and easy with chemicals, accessible chemicals, and I think it was borax extraction. I kind of lost touch with that group when I, in a previous life when I moved on. But I know we've done a lot of work. We documented, there was research done, there were papers published from CSR Mining Tech side And we supplied a lot of information, anecdotal evidence around the mercury exposure in that particular context. And also in conjunction with, as I say, Workplace Health Without Borders, a lot of work done to develop extraction techniques moving away both from mercury and cyanide. The question here is, is anyone in this room possibly familiar with that? Do you know about Workplace Health Without Borders and the initiatives that they've launched and or established in this regard?
Did you get that question, Rico?
Yes, I did. I got the gist of it, I think, but I was expecting it to be directed at the floor. I can make a quick comment, and that is that what artisanal miners mainly lack is access to credit and access to tools. The use of gravitational methods in gold mining and using sluices and using centrifuges, etc., there's a long history of that. And we can quite easily, I think, if there was a national effort to formalizing artisanal mining and working together with them to maximize the extraction of gold, I think through small investments, small technological kind of training and improvements, I think we can provide them with good techniques so that they recover the majority of the gold. What isn't recovered, the tailings that they don't fully recover the gold from, they can then sell to large-scale miners where the use of cyanide and the use of advanced chemistry is used to extract the gold. And I think in that way, you can provide a balanced, co-beneficial enabling environment for safe artisanal mining and also beneficial artisanal mining. The biggest problem with artisanal mining in South Africa is that it is illegal. It is considered an illegal activity. And because it's considered illegal, there is a massive criminal underworld that benefits from it. The sooner we work towards formalization, the sooner we work towards inclusivity and bringing more people into it as an economic activity through basic licensing, etc., the sooner it will benefit more South Africans. And the sooner we can then control it. Because if it's illegal and it's happening, it is uncontrolled. And that is the biggest risk at the moment. Thank you.
Sorry, Rika, just to then maybe direct at you. Are you familiar with the work done in terms of this extraction method not involving mercury and cyanide? And the work Workplace Health Without Borders has done, because I think there's a possibility for collaboration in terms of what you're doing with that organization. Are you familiar with that at all?
Is this the Igoli method, the one that uses borax?
Correct.
That you're referring to?
Correct.
Yeah, I mean it's not that it's a bad technology, or it's not that it just isn't accessible to miners. In order for them to use that borax method, they would need a facility that is close to them. They would need access to that facility where they can extract they can watch the process while it extracts the gold. Not just artisanal miners, all gold miners are unfortunately very, very suspicious kind of cagey people. It's like even dating back to the early gold rushes, these kind of personality traits, we talk about gold fever, you talk about gold rush, all of the terminology kind of supports that. So artisanal miners need access to a technology like this, if it is a technology that we're going to put forward. At the moment, it's limited only to a few refineries, and for them to get their stuff, their bags of concentrate to the refineries, it's a long stretch. So that's why they use mercury, because it's convenient, it's easy. They can use it right where they are working, without having to, without having too much kind of a logistical challenge.
Okay, thank you for the discussion and inputs from the floor. And thanks, Rico, for your presentation. So we are quickly going to have a coffee break, and we need to meet up again 11:30, please.
Thank you. Good morning, everyone. Listen, some of our guests got some vouchers from our little shop at VUT. I think this is now the exact time that we can use those vouchers in the next half an hour before we start with the students. Thank you.
We'll just sit here and feel sorry for ourselves.
Come on, don't do this to us.
I've been looking forward to personally to see what our students are doing in Mercury. Without further ado, we have Miss Anesu Karadzandima from Stellenbosch University presenting a talk on the potential health impacts of mercury in an industrial hub of South Africa.
Good morning, everyone. Yes, my name is Anesu Karadzandima, and I'm realizing the slide should probably be titled Potential Health Risks, just for today, on what I'm going to present on. But I'll explain why. So, yes. The municipal area in the Western Cape, the Saldanha Bay municipal area, is home to a number of people, a great population. I'm forgetting the number now. But in that area, we also found that there's a wide range of industrial activity going on, as well as the Sishen iron ore railway line transporting ore to the port in that area. So as a result of that ore transporting, there's dust that is emitted from the ore transportation, open carriages, and this has resulted in concern about the potential health impacts may be having on the population there. So this is something that's being done now that we're doing in collaboration with the municipality. So just a bit on dust pollution, we know it can have both natural and anthropogenic sources. And for the project that I'm doing, I'm looking at the inorganic components. So just here, that's why I put the diagram, just the inorganic components that can be associated with that dust. So I want to say particulate matter is part of the focus, but for me, actually, I'm looking at bulk dust, and I'll explain how we collect that and everything. But these are just a list of some of the health outcomes that are known to occur from exposure, long-term exposure from dust and particulate matter, and that's why this sort of research is necessary. So I mentioned that, I kind of already gave a brief on the Saldanha Bay area. This is just an image showing the ore, the ore in the carriages in the railway. And then this is just the study map of the municipal area. And we have a number of sites where we've set up samplers, passive dust samplers, to collect bulk dust. And so the reason, yes, let me go into the next slide. But this is my master's that I'm working on. And here I linked a map. But ultimately, what I'm collecting is bulk dust, and then also soil samples and samples of from publicly exposed surfaces, particularly park benches. So with the bulk dust, I mentioned we have passive samplers. With the soil, the idea is to also get a kind of a background understanding of what are the soil concentrations in that area, and then also, because the particulate matter or just dust in general, it settles there's a settling that happens in just short distances. So to kind of see if there's a correlation between the dust and the soil. And then also from the publicly exposed surfaces, wiping those surfaces with what we are called ghost wipes to kind of get an assessment of what are the metal concentrations in that. But I'm particularly looking at mercury. I'm not giving a mercury overview because we've kind of been talking about it quite a bit, but mercury, because of the really serious health risks that are associated with it, and because it can be associated as an impurity in these types of ores, but also in general in the industrial activity that does happen in the area, we can expect or just suspect or just want to see what that looks like and kind of answer the outcries from the public health perspective. And yes, so the bulk dust we collect every 2 months, and then the soil and public bench surfaces I wiped in April, collected in April. And the analytical method that we have been using is ICP-MS, and partly, which is funny because we've been talking about no ICP-MS, but the part reason why is because this is a study that I'm doing in conjunction, like I mentioned, with the municipality, but also in a broader scope where there is a PhD student looking at a host of other metals. And with that, we had started out using ICP-MS, But I think that's why this is the beauty of having these sorts of meetings, and as a student being a part of it and hearing why not, but then going from there. But yes, so then the health impact, or rather health risk assessment, I've been doing using the US EPA metrics, which give an estimation of what are the potential health risks for different potentially toxic metals, different hazardous substances. And then in future, I do intend to do a source estimation just using a positive matrix factorization analysis. I mentioned that the other metals that we also look at, or the other metal concentrations that are obtained, so to kind of see the correlations, or if there are any correlations there. Yes, so this is just, the other map didn't show the soil sampling locations, and this is quite, yeah, the coloring is not great, but the BSNE samplers, we have 5 that are shown here. We installed another one, a 6th one recently. And then the soil samples are located where you can see those brown dots, and where there's the pink ones, it's soil and total organic carbon. And the total organic carbon analysis is one that I did because it's necessary to know how much organic carbon is in the soil samples for you to then do the ChemScan. Otherwise, you can damage the ChemScan instrument. And the ChemScan is the quantitative evaluation of minerals using scanning electron microscopy. I tried to remember that word. And the purpose of that is to kind of see what are the proportions of the minerals in the soil, and then see where mercury might be associated, which, yeah, I'll get into that now. But part of the sample location selection was to do it in close proximity to the BSNE samplers, or at least 500 meters, within 500 meters, just to see if there is the sample types are different, so not to directly compare them, but just to see if there is a correlation in some ways. And then also considering the land use zones. So I'm just mentioning some of the things that went into why those locations are where they are. So the image to the left, this is a BSNE sampler, and it stands for Big Spring number 8. At the back, you see the conventional dust bucket, and we have chosen the BSNEs over the dust bucket just because, well, not just because, but one of the reasons is it aligns according to the predominant wind direction, and then it collects the dust through that inlet that you see there. Sorry, my hand is shaking. But that's the BSNE sampler. And then here's just an image of one PhD student and a postdoc in our research group collecting soil samples. And yeah, that's in the industrial area in Saldanha. Then we also had, not on the water, we went sampling from I don't work with these samples, but this is just an image that I had to use to show the high volume sampler that we have placed in the industrial development zone. And these are images from the collection that we did in April using this high volume sampler. So just a little bit more on the US EPA metrics, and I won't speak in great detail, but then using these metrics, we're able to calculate what is the risk from inhalation, ingestion, and dermal contact of these metals. So yes, there are a number of assumptions that go into this, and I have them in another slide if you do want to see those. But ultimately, it's to give a sort of rough estimate of what could the potential health risk look like, and where is further analysis or just a more detailed look into the population, like the demographic and the health risks that we're seeing there, where that could be done. So these are just more images from when we went sampling in April, collecting the soil, and I realized as I was editing the slide, I removed the image where I was wiping the bench, so my apologies. There were a number of benches that we wiped around the area, but that is just another thing that was happening. The image to the far right is Sanika, another master's student. She's holding the filters that were going to be set up on the high volume sampler, but I don't think it's really visible in the image here. And then Kiremang, the PhD student, holding a BSNE sampler. Okay, so quickly to the results. Here I just kind of brought them all together. Okay, this is from the dust analysis that we've done, and collected samples so far, and these are the sample ranges. I think in questions maybe we can chat a bit more about it, but now I have to zoom through. But with these ranges, calculating the metric, the health risk metric, I found that they're below the critical health risk level of 1, which is stipulated by the US EPA. And yeah, so here I had edited this out. I forgot to send that version instead. But this is more applicable to the next slide, which shows the soil concentrations and the wipes. None of them showed any concentrations, or let me not say didn't show, but it was about the detection limit. The concentrations we could not determine. But looking at these are soil screening values that are on the right there in the red box highlighted, and set by the, well, here it says DEA, but this is now DFFE, I presume, and they're below, the concentrations that we found are below the value of 1 that is stipulated by those soil screening values. So this is just to give an idea of what are the health risk levels looking like. And then down to the chem scan. So from the chem scan, like I mentioned, we can get mineral proportions or proportions of the minerals in the samples. And these are the results. Sorry, I'm going to zoom past, but I just added some of the images, and I'm still working on the analysis and just looking at the results holistically. But the black particle is an iron oxide particle, and this is from that sample that I highlighted in the industrial area. This is a sample from the industrial area. And I just wanted to show the different sizes that we're seeing, and how this is now the second particle. They are associated with some base metal sulfides, and an idea I will speak about that is to look into those base, or like using laser ICP-MS, LA, laser ablation, ICP-MS, to look at those base metal sulfides in the sample, and then see if there is mercury associated with that, because I don't want to work under presumption, but then there is a likelihood that it is. And that's just one base metal sulfide particle. Like, it's tiny, it's barely visible on the slide, but this is just to show what are the sort of particle sizes that we're seeing, and the mineral proportions as well. And yes, so this is very much work in progress, and this is the first year of the master's. But yes, yeah, thank you. Yeah, it says thank you, SAMNet, but thank you all for lending me your ear.
Thank you. Great presentation. You're a good presenter. I don't know why you were nervous. Just one question from me. For your health risk assessment, did you use the dose response function, HQ equal to EC divided by RFC? HQ equals to? EC divided by RFC.
No, not EC.
So yours was for inhalation, right? Not in...
The 3, so I added the different HQs all added together.
I see. Okay, thank you. Any questions? Sir, you can go ahead. The gentleman in the middle.
Okay, that was a great presentation. But I would like to find out, you presented, you said you used your ICP-MS, but with destruction of your sample, I did not see which lexiviants that you have used to dissolve your sample. You need to consider that, because the reason I am asking this, it will improve also. It will be more like a great discussion to link your mineral association with the lexiviant of interest that you have selected. For example, you have results where you have FLEPSPAR and other silica stuff, so you need to check. I mean, I was interested to see the lexiviant that you have used, and that can contribute more in your work if you link the mineral association with the lexiviant of interest that you have used to dissolve your sample. So that's, there's no need to ask for which, there's no need to explain which lexiviant you have used, but I just wanted to focus and check the link between the solvent that you have chosen and the mineral, the information from the QSM, which talks about your mineral association. Thank you.
Thank you so much.
Thank you very much for helping the student. I'd appreciate it. Any other questions from the audience?
Thank you very much. I'm not sure if, because you'll forgive me because of old age, I miss things. Your topic, I think you said health risk, or what is it about?
Yes, so it's on the potential health risks that could be associated with mercury in the dust in that industrial hub, or in the municipal area in Saldanha. I just changed, I said health risk because I mean more the level of risk that is associated. If I say health impacts, it's as if I'm going to tell you what will people get, and that's, I can't say that conclusively at this stage.
Oh, okay. That was most of my concern, because I was going to ask you, because normally when you do such a research, and if it's a health impact, you also have to maybe check the clinics around and check what type of disease are people suffering from, which you can always associate with your mercury and what. So, like I indicated, old age. Yes. Thank you very much.
No, it was a good question. Thank you.
James Chong from Intech. Thank you so much for your presentation. I was just asking my manager this side that he was telling me about you are measuring with ICP-MS and so on, and in the morning we had mercury not really good to be measured by ICPs and so on. Are you considering this kind of equipment? That's number one. Number two, going forward, I was looking at the gentleman sitting closer to me here, looking at forward for your PhDs or your work and so on, because Mintech does a lot of related work like this. What's your plan? Are the SAMNet giving you opportunities or not?
Yes.
There's my task.
Thank you for your questions. So with the first question, sorry, now I'm forgetting the first question. So the second one is immediately what I was thinking of. Yes, with ICP-MS, I definitely, I don't want to say going back to the drawing board, because I do think there is value in the results found. But with that, with what we've been discussing and what I've learned from our meeting, to sort of see how to incorporate the better techniques into the study currently at present. And looking, I can't say if I am looking to buy the equipment, because I'm not the one who would buy it, but I definitely do see value in using something more precise, more robust than ICP-MS, yes. And then I am very interested in research. I think the past couple of weeks have stirred something in me for research. If the opportunities are there, I am there as well. And hoping to have further conversations about that too. Yeah. Is that okay?
Great job, Anesu. Thank you, Dr. James. Next up, I promise you, I practiced. Is it? We have Gian Kemkas. Gian Kemkas from the University of Pretoria.
Thanks. Good afternoon, ladies and gentlemen of the Mercury jury. I'm here to present my humble slice of pie, which is my PhD project, effectively, in a nutshell. I'm going to start with an overview, basically, of proficiency testing that I participated in and how that relates to the fundamental aspects of my project, I suppose. So at this stage, my co-supervisor is Dr. Martin, as well as Prof. Patricia Forbes. And to start off, I want to chat about the proficiency testing itself. It's orchestrated by the National Institute of Multiple Disease under the auspices and collaboration with UNEP. And it's led, and it's been going on since 2020 till present. Currently, there have been 3 rounds. with the fourth round still to come, which we hope to participate in, but I'll get into the details of that now. The aim of the proficiency testing is to essentially enhance collaboration globally and to assess the state of the capacity to analyze mercury in laboratories around the world. And it ultimately relates to the effectiveness of the Minamata Convention, because if you have countries that can do the analyses with reliable data, then you can make assessments off of that. And then in terms of the range of participants, it was both all from institutional, governmental, and private laboratories. So it gives quite a good range on who's doing the analyses. In terms of our participation, we focus solely on total mercury analysis because our instrument is limited to that, as well as methyl mercury is a bit sticky to work with. In terms of the proficiency testing and why it's important, it's a very useful tool to validate methods, particularly when you're analyzing new types of matrices, which is my primary concern. But it's also important because of the sort of wide range of concentrations that you can get in the environment. So, for example, we all probably know that in air mercury is at the ultra-trace level, so we need certainty at that level, not just at the higher levels. And this is for both speciated measurements as well as total mercury measurements. So my basically question that I want to propose is the validity of the data and using the proficiency testing to gain certainty in the data that I will be producing from my PhD. And my primary concern is that if at this stage the total mercury concentrations that are being determined are being scrutinized, then what gives us confidence to the sort of sub-fraction of that as oxidized mercury, such as methyl mercury, because that becomes very important with regard to the bioavailable fraction of mercury that ends up bioaccumulating and biomagnifying in the environment. So I've included this image here on the right just to show you that, you know, that's the biomagnification and why it's critical. They use that in those types of assessments. So with regards to the proficiency testing itself, we participated in 2 of the 3 rounds that have currently happened or transpired. And so for the first round, there were about 26 participating laboratories, and they did not give us a known concentration for the test item that was supplied. But they did, however, give us a standard reference material, which we could use to check the accuracy of our results. And in terms of the results themselves, we only were required to submit a triplicate analysis. We obtained a very low error and a very good standard deviation. And as it stands for the first round, if you can see there in the curve in the top right, figure 3, as they had it, which is from the report that we received back, we were one of 2 labs that participated from Africa, and the second lab was sort of tentatively wrong with their values, if I can phrase it that way. As I said, our instrument was limited to total mercury analysis, and the instrument is here. It's the DMA milestone, which I'm sure the Nippon competition. And in terms of the methods themselves, there was a plethora of spectrometric methods that were used, which are typically used for the mercury analysis. And the sample preparations were also either acid digestion or thermal decomposition. And so this leads me to our participation in the third round. We didn't participate in the second round due to the matrices I want to look at down the road in my PhD. It didn't necessarily align, so we decided to opt out of that. With regards to the third round, which we also passed, and that ran towards the end of last year, they gave us an expected concentration. There were about 34 participating laboratories, so a little bit of a larger data pool. We also submitted another triplicate analysis, and the data did look a little bit better. But this brings me to my next concern, which is the fact that the levels in round 3 for the test item that was supplied were higher in concentration. And this gives us no information about what is happening at the ultra-trace range, which is, again, becomes important when you're looking at the oxidized fractions of mercury. And it has implications in validating these methods at the lower levels, because even though the performance is good at the milligram per kilogram level or the ppm level, the PPT is also still in question. And it's important because your values then, your relative error and your relative standard deviation when you get to the ultra-trace levels is a lot more. So it needs to be controlled a lot more tightly. So that leads to my premise that we need to improve the robustness of our data at all concentration levels. And this is particularly important because our instrument detects to very low levels of mercury, and we want to be able to operate it at that level and determine the concentrations in samples. And so we need more robust quality assurances like reference materials, but unfortunately there's not too many matrix match reference materials for a lot of biological matrices specifically, and it's also challenging to make them for air. In terms of the methods, again, we use the same instruments, it's the same method, and you can see again from the labs in Africa, in terms of the proportion now, we fell into the 50-50 split of those that had passed. So again, our performance was quite satisfactory, and if you look at the top right, specifically for the thermal desorption atomic absorption spectrometry, those were the most common method, firstly, and also the most reliable. I mean, there was hardly any deviation compared to the other methods. Not that the other methods aren't valid. And then from that, it's important, just from the perspective, which I'm sure everyone knows, but it's important to improve the accuracy and the resolution of our data so that we can update our inventories, so that we can assess impacts effectively, so that we can then inform policy, and then it also has elements of modeling, and by that, information on the speciation of mercury and its transformations in the environment. There are other hindrances that are preventing sort of very robust and comprehensive mercury monitoring, and that's from the high cost to obtain the temporal and spatial measurements, the resolution that we want to achieve to be on par with the rest of the world, and specifically the Northern Hemisphere. There's also a lack of infrastructure for active methods, but I know that there have been active efforts by SAMNet to sort of improve the atmospheric network using those, like Lumex. And there's also a lack of skilled personnel, which I suppose relates to what we were saying about getting students into this field. These can, however, these issues and logistical issues and so on, be mitigated by using passive sampling methods. But the problem with that is that the quantitation actually happens with the measurement method, not necessarily with the sampling step. So that's why I want to scrutinize the method per se, and that means that my key focus is going to be particularly validating these concentrations at a lower level and further participation in this proficiency testing so that we can be certain about data that I generate. So in general, this relates to my PhD project, which I haven't touched on much on, but the crux of it is that I would like to generate accurate data for environmental mercury concentrations in different media, so not necessarily just one particular media matrix, but this is to ultimately fill the data gaps that we all know are prevalent in the country. And how would I like to do this? I'd like to first validate my method, which will continue with the proficiency testing as well as hopefully other tests that we can do. And I want to do that by focusing on sort of a site-specific scale, a few sites where I do a holistic sampling of a multitude, multitude sounds like a lot, but a few matrices, both abiotic and biotic through collaborators, and abiotic as is done in the literature. And I want to basically use that to model on a holistic scale what is happening on a site-specific scale with the mercury and the biotransformations. And hopefully that will give us a little bit of insight to what is happening in terms of mercury in the environment, especially in the remote regions where I ideally would like to set my sampling sites, both impacted and less impacted sites. And yeah, so that's essentially the gist of what I have to say. But I would like to, before I end, also encourage that whoever's here or whoever knows of someone that is also doing mercury analyses, to please participate in the proficiency testing, because I think it'll benefit all of us to validate our methods, as well as increasing the pool of data that they have to work with, so they can also make better assessments about how the rest of the world is performing with regards to mercury analyses. So with that, I also want to say thank you to the funding umbrella and everyone that made this happen, and for the opportunity to present, and open the floor for questions.
Okay, so you can go ahead. Sorry, Ken.
Do you want to keep it?
Yeah.
Thank you so much for a great presentation. Just interest because we at Mintech, we also, I think, the producers of certified reference material from the ore bodies, working on projects of environmental sustainability, we also, I think, in our project do some sediment samplings in sites. I think I had a discussion with Prof earlier when she was catching up with me. So that's number one. It's a very interesting work that you do. And I would then take you on a challenge, maybe in the South African community, to pick a site where we can do sediments, do PT scheme, and maybe even formulate our own SRM or CRM for region, even from a sediment point of view, because we will have at least a location where we can get material and treat it well. So we can take that forward. Yeah.
No, I agree with you fully.
Oh, thank you very much for the wonderful presentation. I'm very interested in this because in proficiency testings, because I think it's one of the requirements for SANAs. Most of the labs that needs to be accredited, so you have to do proficiency testing. So I just want to say it's a good job, and we're looking forward to where you now look at the matrix effect. Yeah, so I think particularly the biological matrix. So I think that will assist a lot because that is directly influencing what is happening in particularly human beings and what. So congratulations, it's a wonderful job.
Thank you.
Okay, on your results, I saw that you've projected your proficiency test results within a month. So is it a standard or is it only the ones that you have got in terms of presentation?
I'm sorry, I don't think I understand what you're asking.
The results that you projected for your proficiency test, when I looked at the dates, it takes a month.
Yes.
Yeah, you see. I think even the second one, I don't know if it's a month or 2 months. I don't know if we start on the first or the last.
Sure.
But I just want to know if it's a standard to actually do your generation of data within that time?
No.
Or
so that the window, I suppose, that was provided by the orchestrators of the scheme, the proficiency testing scheme, they gave us that amount of time within which we could do the analyses and report back. So it was a window of opportunity, effectively. Yeah, so it's not necessarily my data that I analyzed over the month. I did it in the lab with how long it took, but it definitely fell within that range.
So you deemed them accurate?
Excuse me?
You deemed them accurate within 2 months in terms of the collection of data?
I would say so, because the results show. And also, we transported them immediately after we analyzed them immediately after we'd received them, rather. So in terms of stability and so on, they also did their checks with regards to the SOM that they provided us. There was sterilization and homogeneity testing and moisture correction and all those kind of QCs that needed to be done. So we do have quite a lot of confidence in the fact that we got our values. And with that then compared to the other labs that participated in the world, we are in good standing, I suppose. Yeah.
Okay, thank you.
This is also Andile from Mintech. I'm just curious, what results that we were presenting, you said you like to say they are wrong or something. I'm just curious about based on what, if you can comment into that.
Based on the report that they provided us. So in terms of the expected value or the values reported by all the labs, they pulled that together, and those that were not within the mean or that didn't necessarily fall within a certain range got a particular Z-score with regard to the statistical tests that they did. So based on that Z-score, if it fell over a certain number, their performance was deemed unsatisfactory and they needed to update their method or check to see if they could redo it to get better results.
Okay.
Based on, because they knew what the expected value was, we didn't. So they compare it directly to that.
Oh, all right. Another thing that I would like to contribute, to suggest in this full work that you are doing, is to also to consider in your statistical data, to consider the uncertainty of measurement. Thank you.
But I think what needs to be mentioned as well is that this isn't my analyses of the data. This is from the report of what we had submitted to them. So they took the data from all the laboratories globally, and then they pulled the data and they submitted this, or they provided us with this. And ours, based on our identity that we know that we fall into the that green, for the 2 labs that are in Africa, we are the green one, based on the identity that on the report. Am I answering your question or calming your fears?
No, I thought these RSDs and mean and errors, you are the one who was calculating them, so I was suggesting you include the uncertainty of measurement so that you can see.
I see. No, so I actually have no information on how this data was fully generated, but it was done through the proficiency testing scheme and
all right,
and reported back.
Thanks for the discussion. Sorry. Great job, Ian. Yeah, great job. Okay, next up we have Miss Debbie Reshane from the Northwest University.
The South African First Initial Assessment Report says cement is the 3rd, if not 2nd, after coal as the huge part of the huge anthropogenic mercury sources. We all know that before, the smelter processes in the mining industry, coal, platinum, chromium, and gold, they were using coal in their smelters. Now recently, they've struck the deal with Eskom to provide them with continuous flow of electricity, hence they stopped using coal. Currently, it is besides incineration, it is the cement industry that is using coal. And the coal that they are using is fly ash, which is just very low grade. That brings to my choice of research. I'll be modeling ecological and health risk impacts from the mining-induced mercury contamination of ecosystems in the Northwest. Why the Northwest? The Northwest province in South Africa, when you calculate the cement industry, seems to rank a bit higher. And in the Northwest, the Ngaka Mudiri Molema is the one with more cement plants, the huge one that has both the quarry and the plant itself. This brings us to the outline of my presentation. It's the background brief, because everybody has been listening since yesterday about the mercury all of a sudden. I'll give you the problem statement, the research aim and objectives, the basic hypothesis, the rationale, and I'll give you the methodology in brief, not in more detail, and the expected outcome. Like I said, we all know that cement is the basic in construction industry. And South Africa, as a developing country, is having more skyscrapers, and that's where cement is being used. But behind the cement, what is happening? Let's continue to hear. Mercury enters the cement plant either through raw material, which is the limestone, and through fire. The fire means the heat source, which is the coal. It is emitted into the environment, into the atmosphere through into this atmosphere, when it is emitted into the atmosphere, it will either settle on the ground or it will be washed off into the rivers, where it then gets into the aquatic life. It will influence the aquatic life or impact it, and the food chain, where we get fishes, and the livestock. In South Africa, in the Northwest Province, it is the province that produces more food, agricultural products. And mercury has a tendency of bioaccumulating and bioconcentration in ecosystems. It has gained the prominence since the beginning of the Minamata disease in Japan that was in the mid-late 50s. And South Africa, as a member party to the UN, ratified the Minamata Convention that started in 2013 in 2019. And all parties that ratified now are required to come up with the implementation strategies towards this Minamata Convention. And South Africa must establish this. And then the detailed implementation strategy needs scientific base, which this study will contribute to. Now come to the cement production. In the cement production, it starts here. It has 4 steps. This is the quarrying steps, where limestone and clay are mixed into the raw mill ground, and then they go into the raw mill silo. And limestone originally has mercury. And then here in the silo, it gets blended into one thing, and then preheating, where the heat is introduced, not that much into the coal mill. When it comes here into the kiln, that's where roasting takes place, and this roasting, that's where mercury gets emitted with flue gas. And then from here, they add gypsum, continue to mill, it comes to the cement, and then get dispatched. The problem statement is that the water bodies and soil compartments surrounding the cement plants are subjected to mercury contamination, which results in adverse effects on ecological and human health. Conversely, people living around the cement plants are not aware of the impacts of cement. They just know, yes, if you ask them, they'll tell you about cough. Other than that, they have no idea. Although the contamination level proposes insight into environmental exposure and burden, a critical need arises to translate these outcomes of the proposal into predictive, precise risk assessment that can give mandatory monitoring, mitigation, and policy interventions. My basic hypothesis is that water and soil contamination near cement plants is associated with higher levels of mercury. And the presence of the cement plant exacerbates this. Proposed aim of the study is to quantify and model the spatiotemporal mercury contamination and associated ecological and human health risks associated with cement. And the specific objectives will be the one, it will be to quantify the mercury concentration, the levels in water, the second in soil, and the third is now to assess the degree of contamination using contamination indices. And the fourth one is to develop a model, the risk assessment model. The rationale for my research is that information on mercury research in South Africa mainly focus on coastal mercury assessment and less or few into the inland. And this creates a gap which this study will fill into. South Africa has conducted the research on the Minamata initial assessment, like I said, to establish national foundation to undertake future work towards implementation of the convention. Although the South African MIA has identified cement plant as the second, if not third, currently there is no published study that has measured or quantified mercury levels in cement plant in Africa, particularly in the Northwest, that has more active cement plants. This creates a significant gap in literature. This will be my study area. The study area is along the Northwest Province, but the Ngaka Mudiri Mulema. The Ngaka Mudiri Mulema is around Mafikeng, Lake Timberg, and when you look at Mafikeng, it's like white rocks. There's no, it's here and there, but there's a lot of lime in Mafikeng. And we have chosen the 3 cement plants, the slurry, the PPC slurry, which is here. And at the PP slurry, we're looking at the water bodies. The PP slurry, that's where the Molopo Eye starts, and then it feeds into Molopo River. It goes all the way, it joins the other ones. And then the second one will be the Sepaku cement plant around Itsoseng area, which is part of the lake. And the Sepaku is producing more cement currently. And along the fence of Sepaku, there's a water body that is known, it's not known, but the villagers call it Stechelspan, which was in the farm Stechelspan. And
Mrs. Tereshani, I'm so sorry, you're out of time. I've been instructed, unfortunately, since we started late, it's kind of affecting the schedule. Prof, 1 minute? 1 more minute?
Okay. The method of investigation, these are the targeted places, the Ngotwane, the Harts River, the Molopo River, the Euphes Dam in Lake Timberg, the CBD, and the matrices will be soil and water. And then why the Ngotwane, it's a control site which is far. There's no industrial activity taking place. And the choices, as it says, the pollution soils, the cement plants, predominant water bodies, the rivers and the dams, and the grazing fields. And the research is experimental, quantitative, and then it has, and the data analysis is of instrumentation is the multimeter, and the instrumentation for chemical analysis will be Nippon 3000. Mr. Gavin said we need to use new technology. I'm part of the guinea pig. And these are the relevant distribution, and then the contamination indices to be used will be the contamination factor, the pollution load index, the geoaccumulation index. And the expected outcome, scientific, will be baseline data on mercury levels as established to form reference point for future monitoring of mercury and to establish the ecological and risk profile of mercury from cement plants. And contribution to the academia and scientific knowledge is identified knowledge gaps in mercury research in South Africa, inland ecosystem would be filled. And this would share insights and foster future research collaborations in South Africa, and to the summer report, which is a tool towards the implementation of the Minamata. In summary, I'll say information established will scientifically give percentage on control contribution of mercury from these areas of emission inventory to emission inventory of South Africa. This will help the scientific and policy communities by providing regional trace gas background mercury data for possible prevention and education measure that is relevant to the South African situation. And finally, together we can make mercury a history. if we all join hands.
Thank you, Mrs. Rishane. So unfortunately, since we've gone over time, 3 minutes, so do we have one or two quick questions from the audience? It's a very cool study, I do agree. Yes, go ahead, please.
It's a very interesting study, ma'am, that you are working on. So, because I could see that your metrics only water and soil, perhaps we had a chance to look at the sediments, river sediments, because sometimes sediments, they kind of like become a reservoir of contaminants. And then during environmental conditions, different environmental conditions, that can lead to the release of mercury or absorbed contaminants into the water surface. Have you considered looking into the sediments? Thank you.
That's a good advice, but if we took soil, water, and sediment, the scope would be too broad. That's the reason. And soil, the sediment and soil, they are somehow interlinked, because the soil organic matter you will get from the sediment and from the soil. Hence, I chose sweeping away from the water in the soil, and the soil that will be re-emission up again. That's the reason, but otherwise it's a good thing. Perhaps if there were prospective students, they could look into the sediment, and then we make a one thing, and then the baseline for mercury inventory. Thank you.
Okay, this one is just a comment. I think you also touched on the niche market, where we're looking at replacing the clinker with coal fly ash, which when it's looked as if it's a green chemistry, but with its challenges, I think it's going to increase the challenges of mercury in the byproduct.
Thank you. And now that actually there hasn't, yes, mercury in cement is being talked about in passing, but not real analysis at the point, at the site.
Thank you, Mrs. Rishane. All right, next up we have Ms. Puleng Molote from home, from VUT.
I gave him the USB.
Yeah, so can we move? So while we fetch your USB, we'll move to the next person. Are you anxious?
No, can have GK. Can just put it in the USB, yeah.
Access it because we didn't have the password. You know, when you
Good afternoon, ladies and gentlemen. I don't know if I have to put my goggles or not, but I think I'll be able to see everything. So my name is Puleng Molete. and I'm doing my PhD with Professor Klink, Dr. Zondi, and Dr. Martin. And then the title of my project is the development of some sulfurized nanobiopolymer-based nanocomposite towards column adsorption in electrochemical detection of mercury-2 in aqueous solution. So the basic thing before I go into the work, the study material, we're looking at the compound that is very cheap, that can be easily accessible, that is environmentally friendly. So our compound is chitosan. Chitosan or chitosan, people are saying it differently. So we are having chitosan as our study material for us to develop this nanocompound that we are going to use for mercury at the end of the day. So my presentation outline is I'm trying to minimize the introduction because we've heard all about that since yesterday. We are tired of that. So now I'm going to go through the objectives, hypothesis, methodology, results that also be followed by discussion and conclusion. So the aim of the project is that, as I've said, that for simple, low-cost, eco-friendly, and efficient nanocomposite material that will be able to remove simultaneously and effectively inorganic pollutants. Now we are talking of mercury. Our subject is mercury today. The specific objectives is all that. There's a long story, but I'll explain it when I get to the next slide. You don't want to read all that. But I'll go to the hypothesis. Then sulfur functionalized nanobiopolymer-based nanocomposite will be significantly improving the removal and the detection of mercury from aqueous solution, specifically when packed into a column. They will show high adsorption capacity and fast uptake of mercury. When used as an active material in an electrochemical sensor, they will enable selectivity, sensitivity, and reproduction detection of trace mercury. This is what we believe is going to happen. Then getting to the next slide. That we're talking, this is our nanocomposite that we are trying to develop, that we've started with. Then it's based on the chitosan. Chitosan on its own is not friendly to any reactions. So you have to functionalize it. When functionalizing it, we phosphorylate it. By phosphorylating it, we are making it to be able to be soluble. Then it becomes hydrophilic, and then it can be able to be used when it's phosphorylated. And then also, to be able to maximize the chitosan, then we are introducing nanosulfur. Nanosulfur, why? Because we are looking at the mercury part, and then the graphene oxide. The graphene oxide also brings the stability of it. So it says that graphene oxide nanosulfur phosphate chitosan composite works as a high-performance mercury adsorbent or sensor because GO spread the stability and stabilizes the structure, and the phosphorylated chitosan chelate metal via phosphate and amino groups, and the nanosulfur selectively traps mercury and then becomes selective for that. So we are trying to focus on mercury. And then together, this hybrid tenant compound is going to, they create a multifunctional, all of them, they create a multifunctional, high-sensitive, and reusable nanocomposite for mercury determination. So now this is our methodology when we are functionalizing the chitosan, and then also when we do the sulfur nanocomposite, because we go into nanoparticle, because we go into add it to our composite. Then this is the method that we use to add our sulfur and our graphene oxide. Then the next slide is it shows when we characterize, these are the effect of all the the parameters that we'll be looking at throughout our research. And then, yeah, all of them, they'll be accessed, or they'll be done throughout our project. So up to the regeneration where we'll be able to see that we can be able to reuse our compound. Then, when we go to application, after we've developed this compound, the application will be on, we'll use the electrochemical studies, and then we'll do the CV, SWV, DPV, EIS. So, and the other application is going to be on using the fixed bed column adsorption. This is the part that we haven't started, is the last part that we're still going to do. And then now coming to the discussion and conclusion, the techniques that we're using. We have different kind of compounds, so I didn't want to bring all single compound because of time and all that. But generally, this is what we have under discussion and conclusion. There's a shift, there's new pics that shows the presence of graphene oxide, and then it shows the bands also of POC, amine, and OH sulfide related on that. With the XRD, we have the broadening, depending on the compounds that we're having. We have the broadened peaks, and then the ones the other way shifting. So it depends on all the results that we're having, all the compounds that we're having. And then the SEM, we use the SEM, which gives us a smooth morphology with all our compounds. But some, yes, they were not there. But mostly what we are focusing on, they gave us a smooth compound. And then the TGA shows that the improved, thank you. Thank you. So the TGA, because the presence of GO helps with the stability. So the TGA helps, it shows that we have a more stable compound when our compound has that GO. And the BET surface area, we've seen that there's an increased accessible surface area against the normal chitosan. And then also the electrochemical studies did their sensing, and then the IEC, and then enhanced signal was it enhanced it shows the enhanced signal due to the peak current and lower LOD due to the GO conductivity, sulfur affinity, LOD level of detection. And the electrochemical impedance spectroscopy showed the lower charge transfer resistant due to GO. So that's my presentation. That's the end of presentation, bringing you to my project. I'd like to thank the SAMNet. I'd like to thank the VUT for my study.
Thank you, Glenn. We've made up 3 minutes. Just an announcement, sorry, Gia. We were supposed to have lunch at 12:45, I'm aware, but since we started late and we have only 4 speakers remaining, I've been instructed by the boss that we should proceed and finish. Okay. Was that going to be a question? Yeah. That's answer 1. Okay, Gian, you can go ahead. You want to, Pulain, are you ready? You can go ahead, Gian.
Okay, so maybe I missed it, so forgive me for that. In terms of the material development aspect of it, you are stabilizing with your graphene oxide, yes? Is that as a powder, or because predominantly graphene oxide comes as a powder? So if I understand it, it's a powder that then has your chitosan polybiopolymer that's phosphorylated, and then underneath that, or sequestered in that, is a sulfur nanocomposite or nanomaterial. So, okay, that's fair, that clears that up. And then my second question for you is also, have you considered the fact that it's a biopolymer, and it probably then is biologically labile? So, do you not think that there'll be issues with biofilms, or if you want to deploy this new material in water to absorb mercury selectively from the water, over time, biofilms may sort of form and then clog up the surface. So have you had any food for thought about that? That's just a curiosity question, that's all.
Yeah, that's a very interesting question. I'll look at that. We haven't thought about it. Thank you.
Okay.
I have to talk to them.
Okay, thank you for the beautiful presentation. If can you please just go to where you have a table? I just have one question, and also the suggestion. Yes. I want to find out if this whole table, you have done the work already. If you did, next time when you present, show us, because the main part of this work is, we are saying, the electrochemical detection of sensoring. At least you must have the, if you are talking about the electrochemical sensing, we need to see the voltammograms of your material, because some of us here, maybe we have expertise in electrochemistry, will suggest maybe you need to increase your scan rate or to decrease your rate. As things stands, there is no signature of any of the material that you have used. And also for your FTIR, we are not sure if those peaks that you have presented there, they actually have those absorption bands and all that. So I would like to advise you, please, you will have get a great advices if you were having the spectras from this table. Thank you.
Thank you so much.
We have time for one more question. From Prof.
Maybe I can just talk loud in the interest of time. You mentioned on one of your slides reusability. How do you plan to remove the mercury once it's bound so you can reuse it?
We haven't done that part, but we're just going to go, like, haven't gone into thorough details on that one, but we're just going to test it in water, and then run it through some samples, like our water sample, and then get back and dry it to evaporate some of the samples. That's what I'm just thinking broadly, but we haven't done that thoroughly. So maybe you can advise on that one. Is going further.
I don't know if you want to advise her, bro. Okay, thank you for the thank you, Puleng. I understand 10% of your presentation, which is a lot. Thank you so much. Presentations on just yours. It's safe to remove, Puleng. Okay, next up, also from VUT, we have Ms. Lakeni Tutsane. Hope I pronounced it correctly.
Greetings, ladies and gentlemen. My name is Lakini Chuchane, and I am going to be presenting on my project, which is on the comparative analysis of atmospheric mercury using customized adsorbents and commercial purpose for enhanced detection sensitivity. This work will be under the supervision of Prof. Klink with co-supervision from Prof. Somerset and Dr. L. Martin. Air quality is reflected in concentrations of heavy metals, and it is one of the critical indicators of critical environmental indicator. And mercury is a concerning pollutant. We've heard about the ASGM as a pollutant and coal-fired plants as being being the top pollutant in South Africa. So we're gonna skip into literature. We've evaluated the materials and techniques, and we found that active and passive sampling are the most commonly used, with passive sampling being cost-effective and simple to operate. We saw that we went on to the sulfur-impregnated carbon, the silver nanoparticles, the sulfur and the titanium dioxide, and we found that they possess large surface areas and other good qualities for adsorption. Okay. Mercury emissions in Gauteng and Mpumalanga area pose an environmental concern, and there's limited data on the concentrations around these areas. So this limited data hinders the compliance with the Minamata Convention. Our aim is to advance atmospheric mercury monitoring through a comprehensive analysis of customized adsorbent and commercial MOPAs, focusing on enhancing the detection sensitivity and evaluating their performance in diverse environmental conditions. To do that, we will design and synthesize our adsorbents. We'll functionalize our chitosan as well as our multi-walled carbon nanotubes to enhance the mercury adsorption capabilities. We will dope them with our nanoparticles to form the two variants, which are the phosphorylated chitosan multi-walled carbon nanotubes with silver, titanium dioxide, and sulfur, and the other one will be the phosphorylated chitosan multi-walled carbon nanotubes with silver and titanium dioxide without the sulfur. And then we will characterize our adsorbent material using analytical methods, and then we will conduct our atmospheric mercury monitoring using both the MAPAS and our customized adsorbents, and then later we'll develop evidence-based recommendations to optimize monitoring. Our hypothesis is that the prepared or customized adsorbent will be as effective as the commercial MAPAS in absorbing mercury. For our methodology, we will be modifying our chitosan using the phosphorylation to get phosphorylated chitosan, and then we'll be modifying our multi-walled carbon nanotubes to oxidize multi-walled carbon nanotubes, and then we'll synthesize our silver nanoparticles, sulfur nanoparticles, and titanium dioxide nanoparticles. We will then incorporate everything to form the phosphorylated chitosan multi-walled nanotubes with the sulfur and without the sulfur. Our adsorbents will be characterized using the FTIR to find our functional groups, SEMEDX for the POSAs. Okay, I forgot. And then the TGA for the thermal stability, and BET for the surface area. Our customized adsorbents will be inserted in the red area there. So there'll be 3 samplers in each site. One will be the MAPAS, which contains the sulfur impregnated carbon, and then the 2 will contain the 2 phosphorylated chitosan multi-walled variants. These are the areas in which we will be deploying our pesta samplers. Areas around the Matla power stations, Sasol, Letabo, Hendrina, Tutuga power stations, which are areas that are close to the power stations. After exposure, we will analyze the mercury using our mercury analyzer. To summarize everything, we will synthesize our adsorbents, characterize them, and then we will disperse them. And then after the exposure, we'll analyze our adsorbents using a mercury analyzer. These are the references that I used to compose everything, and those are my acknowledgements. Thank you.
You can keep the mic. Thank you, Lakeni. So the real speakers are really fast. You were talking by the way. So, any questions for Ms. Lakeni? Any questions from Prof?
Thank you very much for an interesting talk. So obviously passive samplers rely on diffusion. So the air has to diffuse to your sorbent material. And the MOPAS, that's through a mesh, basically system, cylinder. But you're dealing now
since I haven't gone through that, I haven't really decided how we're going to do that. But I am going to look forward to seeing how to do that. For now, I'm still going to try and look into it.
Can you hear me? Okay, sorry, to turn on. I just wanted to ask, with regards to sort of the chemical interactions with, you're assembling this sorbent from all these precursors that you prepare, the multi-walled carbon nanotubes and the silver and the sulfur nanoparticles, etc. But in terms of the analysis, you probably aren't thinking about reusability of these, because from let's say the carbon nanotubes, those are probably structurally or thermally sound enough to withstand high analysis temperatures and all that to quantify the mercury. But with regards to the silver nanoparticles and the sulfur and all that, that'll probably come off or oxidize or go through your system or your catalyst, depending on what your analysis method is. But my question is, do you see potential in reuse of this sorbent that you're developing, or these different ones that you're...
Since we are using the MA, I don't think it's possible, because after the analysis, then we throw everything. Then that's...
Okay, so then from a cost perspective, do you think it's viable, like going long term, to then monitor on a larger scale? Yeah.
Since they're cheaper, then maybe it is. I think so. Yeah.
Okay, fair enough. Thanks.
Thank you, Prof. Is our next speaker Mr. Zenande? Yeah, you have to come up, boy.
Greetings and salutations to all. Standing before you, as mentioned, is Zenande Kabase. And I'm a freshman in this University of Mercury Analysis. So yes, I'm looking forward to the journey and looking forward to learning as I go. So I'll be presenting my snapshot of my study, which is the assessment of indoor mercury in Sasolburg, South Africa. And basically it's a study whereby I'll be looking at the indoor mercury concentrations and quantifying them. And then from quantifying those, we are going to compare them with ambient mercury concentrations to see if there's no relation there. But also one reason for this, it is because through my research, through my reading, I found out that there's a lot that has been done on ambient studies, but when it comes to indoor mercury concentrations, they've not been quantified. And there are reasons for that, which will be stated. So now we have this problem whereby we have this unturned stone in this mercury project, or in this mercury work that we are trying to do. And so that's basically what my work will try to uncover. So it has been mentioned, or key point has been mentioned, but just to pass by, as I said, even though much has not been said in historical times in terms of mercury studies within the interior. Recently, as we have seen, there's been an impressive amount of work that has been done. However, as I've said, the work that has been done, it's more focused on ambient mercury concentrations. And through reading, we realize that there's also a gap in indoor mercury concentrations within households that are burning or that are combusting coal. And then we have also seen that many studies, as I've said, they've looked at characterizing mercury emissions from coal-powered power stations, and others from the use of dirty fuels, and others also from particulate matter. But when it comes to indoor mercury, nothing has been done from what I've searched. And furthermore, upon this, or to add on to this, there's a lot of work that has been done in ambient within the interior region. And then most of the focused work is on the Highveld priority area. And this is due to the presence of most of the anthropogenic sources of mercury. But then there's few studies that are there for the other priority areas like the Water Bojanala and also the Val Triangle. And part of the study or part of the selection of this study area, it is to also bridge that gap so that we can have almost all these priority areas represented within this mercury scope. And then without quantified and spatially documented mercury concentrations across both ambient and indoor settings, regular compliance cannot be assessed, and evidence-based mitigation strategies cannot thus be formulated. So this is what my study seeks to address. I think I've touched on the problem statement, but as I've mentioned that one reason attributed to the lack of indoor mercury concentration studies is the high cost of the equipment that is required there. And also to add on to this, the lack of awareness and inadequate regulations, they add on to this problem, and thus they result in indeterminate and uncharacterized concentrations of borderline mercury pollution within the indoor environment. So my aim for this study, it's basically to analyze or to assess the indoor mercury concentrations and to understand the community perceptions on the pollutant in Sasolburg, Zamdela. So my objectives are to explore community perceptions. So the reason for this, it is because since it is a study that I've not read it to be done as yet, we need to take a different approach, an exploratory sequential method in order to address this. Then after getting the community perceptions, then we can look at doing indoor mercury concentration measurements, and then we compare those with ambient measurements. Then the significance quickly is that the concentrations have not been quantified, and furthermore, the emission factors for low-income areas have not been established and quantified, making the objectives of the study very significant. And in adding to the existing limited pool of knowledge on mercury emissions. And also the findings of the study, they aim to catalyze the formation of threshold standards that are tailored for the environmental context of urban informal settlements. This is the study area. Primarily why we chose Zamdela, it is because one, it is in informal settlements whereby we find hubs whereby coal is still burnt by most homes due to the crisis of not having electricity. And Zamdela also, it has households that utilize these, and also it is because of it is near to one of the mercury emission sources, which will make it great for the study. So my methodology for this study, as I've mentioned, we're first going to look at the community perceptions, and to decide which area of Zamdela we're going to sample. We're going to use GIS auto-spatial correlation and to decide where we, or which part of Zamdela that we will sample, and then from also after determining the households that use coal through this method and deciding the segment that we will sample, then now we will sample 10% of that that segment. So the number of households within that segment, we're going to count them, and then we're going to take 10%. And then from there on, we're going to start off by using surveys in order to get these community perceptions. Followed by that, we're going to use the Nippon EMP3 Gold Plus in order to what? In order to measure these indoor mercury concentrations. Just a correction there, as we've heard today, that it is not 2.3 nanograms, but it is 0.18. So, so as we've heard also that this is a very good instrument, or why the choice of the Gold Plus, it is because we've initially had the EMP3, but since considering that within the households, the concentrations might be they might need something more sensitive. So hence the choice of this. And then after that, we are going to use we're going to deploy 3 MER plus sensors, and then they'll be deployed strategically within the vicinity of this community. And then after that, we'll take all of that data, and then we will do a comparison of both of the indoor and the ambient. So the limitations of the study, which is my last, is that first of all, there's limited resources. We only have one survey meter. Thus, we can only focus on just one place or on just one household. And there is a very strong limitation. And then also the time frame is that each household will be sampled for 1 week and not longer than that. And then another one is that VOCs released during coal combustions are not accounted for due to financial constraints, as I've been told that such equipments, they are quite costly also. Otherwise, this is my study, and thank you for your time.
The room temperature evaporates quickly. Thank you. Any questions? Prof? Expected a question from you, Prof.
Thank you very much. Sounds like an interesting study. So I see you plan to sample in the households for 1 week, but your meter has 2 6-hour batteries. And you said that these houses don't have electricity. So how do you plan to resolve that?
Yes, there is a problem that came across as we thought about it. So these batteries, they can last up to 6 hours, you see. But it is something that we are also looking into. We are also considering maybe getting even or looking into other methods that can help us to get power as we are doing this.
So Prof, we haven't got into the logistics for now.
Yeah, the power consumption on that EMP Go Plus is not that high. So with that inverter or even those lithium-ion camping battery can allow you to run a day, full day, non-stop.
But since the instruments then will be left in, low homes. I'm not so sure about how safe our would be.
So your idea of sample for a week is like continuously in the home for a week, or just a spot sampling around the community for a week?
Are you asking me
Yes.
one home per week?
Yeah. Is that a one home per week continuously?
So ideally, we would like to compare summer to winter, and since we only have one of these instruments, it's very difficult to figure out the sampling strategy. So for now, we're thinking, if he's going to do these interviews, then we identify homes, about 20, 50, something about that, where people actually burn gold, and we select 10% of the respondents, and then in summer we take 2 months, and in winter 2 months, and that should allow us to get to each of the selected homes for a week.
Okay.
I cannot remember, but I figured out the math. I just can't think of it now.
Okay. Yeah. Thank you.
One more question, please. Nothing? Okay, and then good news. We're moving to our last speaker.
Sorry. Let me just time myself and make sure. Afternoon, everyone. In the interest of time, I'm going to be skipping through my master's thesis because I've been instructed to try keep it as short as possible. Hopefully, you guys enjoy it. So my name is Victor Mugabe, and I'll be speaking to you about my master's thesis based on determining the source and distribution of atmospheric mercury over the Southern Ocean. So you'd probably be wondering why the Southern Ocean? Well, Southern Ocean is central to oceanic systems where you can have exchanges in gas, nutrients, and heat. And this is also important in the context of mercury because downwelling and upwelling processes that occur in the Southern Ocean can affect the availability of mercury in the Southern Ocean for re-emission. So I'll be skipping the research objectives, but the gist of it is that basically the study, we just wanted to better understand the geochemical cycling of mercury in the atmosphere, assuming that in the Southern Ocean, most of the atmospheric mercury or background concentration is influenced by oceanic evasion. So how we did this is we were on a cruise from Cape Point to the Southern Ocean. The red limb you see here is the trip south, and the green is the trip back north, with the white lines basically indicating oceanic fronts where we expected different sea surface temperatures. Therefore, different temperatures, you have different geochemical cycles in the ocean, and ultimately different evasion rates into the atmosphere. And of course, most of us are familiar with the Tekran instrument that we used for observations connected to a sampling line that went outside the ship. So this is what we found. It's basically a figure or graph of our gem concentration against latitude. The blue dots and line indicate our southward trip toward the Antarctic being that side, and then the northward being around where Cape Point is. And we can clearly see that the southern trip showed like a gradual decrease from north to south, but that is not shown in the northward trip as well. But in this study, we'll mostly be focusing on the reason why we have this peak here, which is above the normal background concentrations in the Southern Ocean, as well as these depletion events. And just to see where the air masses that influenced the gaseous elemental concentrations are coming from, we modeled using the NOAA high-speed model, 7-day back trajectories every 3 hours, and we could see that most of the air masses were largely oceanic, 83% oceanic, 10% Antarctic, and about 7% passed through the South American continent. So basically what this means is that we had very little terrestrial influence on our gaseous elemental mercury concentrations. As I mentioned before, we'll be focusing on why we have this peak event here,
And after doing a back trajectory of that peak concentration, we realized that the air mass during this time when the peak concentration was observed, air mass was coming from the Antarctic region. And one possible reason for this is this process here, which is bordered in red. Ignore the label of the Antarctic here, because I got this image from a Northern Hemisphere paper, but the same process applies for the Antarctic region. But basically what we suggested could be happening is that you had photolytic decomposition due to solar radiation, and this photolytic decomposition decomposes previously deposited oxidated mercury on the sea ice, and this is then released into the atmosphere, and you have like a short time frame where you have high releases of mercury in the Antarctic region. Then you have air masses that transport this signal northward toward where the peak concentration was detected, where the ship was. And our other objectives was just to see what environmental factor influenced the gaseous elemental mercury concentration. And basically what we did was we plotted the photosynthetic active radiation against latitude. PAR is basically just the amount of solar radiation that plants use for photosynthesis. Although it's not a very good indication of the total solar radiation, but it's important in terms of just, it's useful in terms of just determining diurnal cycles during the gaseous elemental mercury concentrations. And one thing that stood out is that if you look at the graph at the bottom here, we have this depletion event, which coincides with this one. And you can see that we had low concentrations during this high or peak solar radiation or PAR, as well as the depletion event was sustained during low PAR values. So that means this depletion event was sustained for a period of close to 24 hours during times when there was low solar radiation and high solar radiation. Therefore, we assume that it's most likely not, solar radiation was most likely not an influence on the gaseous elemental mercury concentration during the voyage. And we also studied the wind speed and air temperature on the gaseous elemental mercury concentrations. And the figure on the left is just a windrose with concentric rings that indicate the wind speed, and you have your cardinal points indicated by north, south, east, west. And you can clearly see that the very high concentrations above 1.3 nanograms per cubic meter were coming from the western direction, and the mostly result of wind speeds above 15 meters per second. We also had lower concentrations below 15 meters per second, and then the very lowest concentrations below 1 nanogram per cubic meter were coming from the southern direction, which is the direction where we have the Antarctic, of course. And that basically shows that low concentrations like those depletions are basically indicated were coming from the southern direction. And we also looked at the GM concentration against air temperature and tried to see the influence of air temperature on the GM concentrations. From the figure, we can see that there's a high correlation between the GM concentration and air temperature, and this is an exponential relationship, as you can see. It basically indicates there could be an influence of air temperature on the GM concentration, but obviously correlation does not equate to causation, so you just take that with a grain of salt. And yeah, we also, I previously mentioned that we also looked at that gem depletion event, which is this one that lasted for about 24 hours. And we tried to see why it lasted for about 24 hours, but this depletion event here only lasted, or these two depletion events, it's not very clear on the dots, but then there's two depletion events that only lasted for about a period of a few hours, about 3 hours, but then the third depletion event only lasted for 24 hours. And we saw that the reason why it was sustained for a very long time could possibly be due to the presence of an inversion layer, which is basically when you have very little mixing, vertical mixing of air masses in that region. Therefore, you have an air mass at the bottom, which can basically be where you have a lot of oxidation of mercury being deposited, and then that air mass is, has very little gaseous elemental mercury concentrations and little mixing with vertical air masses. Therefore, it lasts longer and takes time to come back to background concentrations. And the last thing we looked at was comparing this gaseous elemental mercury concentration along our transect to a known background station, which is K Point, where we measured the concentration of mercury at K Point and simultaneously measured the concentration of mercury along the transect during the same period of time. And what we see that there is some sort of correlation when it comes to the depletion events during the southward voyage. But then when you look at the peak events, you can see that there's only one peak event here, as well as 3 peak events in the K Point dataset. This is quite weird, as looking at the back trajectories, most of the air masses were largely oceanic. But something that stands out for the dataset at K Point is that we had the air masses that reached K Point at some sort of retroflexion, whereby they go towards South Africa or the Northern Cape, then they come back down towards K Point. So that could possibly indicate some sort of terrestrial influence, where the air masses first go inland and then bring terrestrial signal back down, and that is then detected at K Point, possibly influencing these peak events we see here. But of course, we tried to look at why we had this depletion event at K Point, but no depletion event in our oceanic data set. But that still needs further study. We couldn't determine why that could be a reason, or why we had a peak here, but we don't really have a similar peak in our oceanic data set. And this is just a summary of what I went through, but since I didn't go through everything, I won't be going deep into this, and I think I'll end my presentation there. Thank you.
Thanks. I have a few points when I can speak. I have answers for you. Speak later.
I think we can catch up with Victor during the break. Thank you for sitting through the sauna with us. So we're going to have lunch now, and then after lunch, we will move to the main auditorium where there's aircon and everything is cool. We will have the closing and just the final wrap-up. So we also take into account that some of the folks will be driving back home, so we don't want to get you all stuck in traffic. So if 1:30 now, if we can all be in the main hall at 2:15, so we've got a lunch break of 45 minutes, and then we will be able to finish hopefully before 3 o'clock. Yeah, so that's what we are aiming for. Thank you. I was thinking I was gonna stand on the stage and then I'm gonna say, just wave your hands in the air like you just don't care. It's Friday, it's Friday. So we've come to the end of a very successful 2-day symposium. And if I had sunglasses, I would put it on and then I'd have said after this, the previous session, the future looks bright in Mercury research. So for all our students that presented, please just give them a very nice round of applause. Mercury research, the future is in very, very good hands, and we will encourage you to continue. For some of you, it might have been your first presentation that you do in front of an audience. It's now the past. You can only from now on. So if there was a hiccup, it's okay. Don't worry about it. Next time, you just do it better. Yeah. But again, from my side, also, it went very well. And some of the research that you are doing, take also some of the comments that were made. Take it and go think about it again, and maybe you can implement it in what you want to do. Or yeah. So thanks for that. We were supposed to have a session like yesterday, but because of time, I'm just gonna give you a quick feedback of the 2 days and how I see things moving forward. There will definitely be interaction, after via email, maybe a few online meetings before the end of the year, and then we can set up things very nicely for 2026. So we started yesterday where most of you have heard about SAMNet, but you really had no idea what actually we do or what is the ideas or the objectives of SAMNet. But I think after today, you have a better understanding of what we're trying to achieve. I think in the slide I mentioned that the key thing for us is that it needs to be a coordinated network. We have a lot of researchers, we have a lot of industry doing Mercury research, but if everybody's in their own silo and we don't talk to each other, we will definitely be duplicating, wasting resources, which is so valuable in the day and age that we find ourselves in. So a platform like this gives us an opportunity where we can come together, see what each other are doing and how we can complement each other. And in a way, in a constructive way, how we can also coordinate this type of research. So that is basically one of the main ideas. And then also, one of the outputs is what we are doing. At the end of the day, we want to see that it will inform policy, of course, but also one of the areas which is definitely lacking is the health aspect of Mercury, which we definitely need to look in. Unfortunately, Dr. Renee Street of the Medical Research Council, that is also part of the project steering committee of SAMNet, wasn't able to make it. So we are definitely trying to expand into that field as well, but we definitely need more work from the air perspective. We are covered, we're on good track. Also with aquatics and water, we're in good shape, but I mean there's always room for improvement. We will also be starting the modeling aspect soon next year. For one of the students will register at the University of Pretoria. So in that aspect, we are also trying to expand. So we definitely looking that all compartments of Mercury, doesn't matter the matrix, that we can at least have at least one researcher at an institute in South Africa looking into that. And when we come together, we will definitely be able to see the whole picture for South Africa. So that is the ultimate goal at the end of the day. Sorry. So I hope you've enjoyed it. You have learned from each other, but also that you have made new contacts and new networking contacts here. So I'm hoping that in the next few days or even over the weekend, there will be an email or two flying around and just talking about what you've learned and how we can interact. Sorry. So thanks again from my side for everybody's input, for coming. A special thank you to our guests, our international celebrities. They were definitely treated like celebrities here at VUT, and also for Alvin from Singapore, that was part of the team. Thank you, everybody, for coming, and then also our host also here, Prof. Klink, for taking care of the arrangements and all that. Thank you, and the rest of the VUT team. The VUT team, in the absence, thank you from my side. I think we've been able to put something together, and the product that we have at the end is something of good quality. I'm going to give over to my senior manager that's just going to say her final remarks. Thank you, Dr. Katlego.
Okay, thank you, Dr. Lenwin, and thank you, colleagues. I think you have covered us in terms of extending our sincere gratitude to everyone, from our international experts to VUT, for the supervisors and the students and those that came here to provide their valuable input into the research that is going on. So we really, really appreciate that. That is part of us growing and improving and capacitating and supporting the initiative. And yeah, what we see is just great work, great consolidation, growth, and much important, the impact, the tangible impact into the global program. So otherwise, we're grateful. We're hoping that what was discussed yesterday in terms of the vision, you know, and I think what I've noted is that we still really much, and I'm not sure how we're going to go about it, to get inputs from the students. I think yesterday their voices in terms of that which was being discussed, it was not that much coming through. And for us, it's important. It's like in a house when you are cooking something, you can't just cook anything. You need to be able to ensure that everyone, you know, it will be able to eat up on that. So it's very much important because it is about them. Ultimately, who are our future generation, the people that will be taking these forward and bringing those innovative ideas, ways of doing things, new methodologies. So for us, I don't know, we'll find a way, even if it's a survey of some sort, that will be circulated so that they can be able to provide those input to say what is it that they think this consortium can do, can achieve, especially taking them in mind and putting first, you know, their needs. Otherwise, we appreciate so much all the valuable insights, all the presentations which were well placed. You know, we really, really appreciate, and we believe that we can only grow from where we are. I thank you on behalf of the Weather Savers, our CEO, our executive. We really, really appreciate, and and much thanks to the DSI also for the funding that continue to expand and expand. We are really, really appreciate. And we hope that going forward, there will be those additional partnerships in terms of private as well as from other departments as we try and consolidate. Thank you.
I think just to add on, in terms of the students, you know each other. I think amongst yourself, you can start a little small group or whatever and just chat to each other and see how you can contribute. And I mean, if there's any suggestions, you can email it to me, and we can definitely discuss it when we have our next project steering committee to also have input from your side. So amongst yourself, yeah, I would say that would be my suggestion. Then we're going to ask the DVC Ricky. Ricky. I'm not sure what Ricky stands for, but the DVC Ricky of VUT, Dr. Speech. He will give his speech. Thank you, DVC.
Thank you, Doc. I think we have not come to an end, it's a beginning. I didn't attend this gathering last year, but I see that there is some developments, it's growing. So we want to see that. I've not spoken to Dr. Kling about this. To formalize our commitment as a university, we are planning, or I've decided, that as part of the plans for next year, we'll kind of work towards having a center on mature research. Because if we don't make that commitment, then the whole thing will die. I want, the plan that we want to have something that can progress from whatever level to a higher level. We also don't want the issue to be centered around one person. We want to be institutional. So that Prof. Klink, as he focuses his research on mature research, there's support around him. So we're in the process at the university of clustering our research, because we're a small university. So we need to make sure that all the components or the activities are focused. So that's why I feel that he has to now work on the proposal that I will take forward to the management of the university and to the council. In that way, whatever support he gets from external agencies like South African Weather Service, ESCOM, Mintech, and everyone else, at least there is support coming from university. So we are confirming that the issue of mature research at VUT is no longer a Prof. Klink issue. It's a VUT issue. All right? I thank you, colleagues, for allowing VUT to host the second leg of this gathering and also this forum. And I also want to thank the fact that you brought colleagues from Japan. Thank you, Elvin, for bringing people, like I said yesterday. We also confirmed that we're coming to Japan next year. I've got the money to travel, so yeah, I've approved. Yes, I've approved. So our budget process has not been finalized for 2026. So as part of the budget, I've included travel to Japan. Thank you, South African Weather Service. To you, sir. Thank you very much.
Thank you, DVC. Thank you, DVC, and also for that commitment that we can see the continuation of what has started. I'm going to give over to Prof. Modise, the HOD, for the closing remarks and closure.
Well, thank you very much. Today I will not speak Japanese, like last night. And I must declare also, I did not speak Japanese because I drank good water. It was not under the influence, it was deliberate. Thank you very much, DVC, for the commitment we made. I just want to follow up just on that. That next year, around this time, VUT will also be hosting this conference. Meaning the commitment from our side is that this will become an annual event. So we have in our budgeting now, have to stretch it a bit to accommodate this. Prof. Klink, as you go out, when you said it is a symposium, I was asking where are the t-shirts? Where are the bags? Where are the goodies? Where is what? Where is what? That it reflects that it's in fact something is happening there. And students are asking, we see a gathering there. What's going on and all that? So the commitment is that next year, going forward, it will be bigger and better. Thank you, Prof. Klink, for bringing this to us, but also thank you to SAMNet to choose VUT and orient us in this direction. We highly appreciate that. Thank you. There are a few things that I wish to apologize for. The first one, when you were heated in that venue, in the oven for the whole morning, it was not deliberate. I don't know what really was happening, but we are told that it was a systems failure. So DVC will tell you that you are on one campus, there is yet another campus, which is a secret gem to VUT, which has better conference facilities. But the facilities there are being developed to be upmarket type of conference venues. So chances are that come next year, this is where we'll be meeting. So I assure you that you will not experience what you experience first in terms of being in the oven, to the food that we ate yesterday for lunch, we got a lot of complaints. And South Africans and the meat. We will not torture you anymore. We promise that is not VUT. I guarantee you that is not VUT. So we'll fix that going forward. So on behalf of the Executive Dean who's held up with the SRC issues, the Department of Natural Sciences, the organizing team that really on emergency basis went into the mode of organizing. We want to thank all those that came, deliberated on the issues. We want to thank all the students that participated. I saw all the nerves at different levels. If we were to measure the nerves, I'm sure we would have collected a lot of data. But that is how it is when even the professors get nervous. It's not only you. Okay, so we want to thank you for and I want to echo this word, the quality of the presentations. It was marvelous to see from industry to academic to research agencies. You looked at the quality and the effort that is taken. And that simply says to me, the togetherness that is there simply says, #no more mercury, the end of mercury. So we want to move with that slogan going forward. Let these words, #no more mercury, not just be a slogan, but be a slogan where we can measure the impact. If we fail to measure that impact and we fail to see change, then we are busy with nothing. So I wish you well as you go back to the countries, and Pretoria is also a country that we have a lot of, as they go back to their country because they go into heavy traffic. Those that will be traveling back to Cape Town, enjoy your flights, and we hope that your flights will not be cancelled because there's a lot of mercury in the air. And to Japanese, I see you, I can confirm that the 1st of November I will be in Japan this year. So hopefully we meet at another university. So all the best, good luck, and build up on what you presented today. All the best, and thank you, thank you, thank you. I can now declare that, firstly, this symposium, number 1, was successful. Normally we vote on that. Was successful, but by the power vested in me, it was successful. Secondly, this meeting is adjourned until next year. Thank you.
The karaoke will start now, so Mantek will be our first performance on the stage.